logged in that webex? जी webex link से login करिए.
Hello. A very warm good morning to all the distinguished dignitaries, respected faculty members, all the attendees who are here to attend this very amazing program in its own merit and light, and all the participants who are in this hall. On behalf of Maulana Azad National Institute of Technology, Bhopal, I extend a warm welcome to all of you at this inaugural ceremony. As we all know that any auspicious occasion in our country starts off by paying our tribute to the goddess of knowledge, the goddess of wisdom, Ma Bhakti. So, to continue the tradition, I would sincerely request the Director, Shri G. Harikrishnan, the Associate Director, Dr. M. A. Paul, Director, MANIT Bhopal, Professor K. K. Shukla, and Professor Savita Nema to kindly come on the dais and lighten up the ceremony so that we can have an auspicious start to today's program. Thank you very much, Sir Sinman. Now I would request Professor Savita Nema, Coordinator, STIC, MANIT Bhopal, to kindly deliver his welcome address.
Good morning all. It is my great honor and privilege to welcome you all on the ISRO Academia Connect for Central India, hosted by MANIT Bhopal, on behalf of Space Technology CBPO ISRO Headquarters, Shri M. Ganesh Pillai, Scientific Secretary ISRO, Dr. M. A. Paul, Associate Director CBPO ISRO, Shri Nishant Kumar, Deputy Director CBPO Bangalore, and all scientists who have come from different centers of ISRO like Vikram Sarabhai Space Center, Liquid Propulsion System Center, UR Rao Satellite Center, ISRO Telemetry and Command Network, Space Application Center, National Remote Sensing Center, Master Control Facility, ISRO Propulsion Complex, Satish Dhawan Space Center, Physical Research Laboratory, Area of Human Space Flight Centers, and RAC Space RACs and SSCs. We also welcome delegates and academicians from STIC and RAC of other IITs. Your commitment to building academic partnership is what makes initiatives like this truly impactful. We are truly privileged to host this event in association with ISRO. Today we will witness the inauguration of Space Technology Incubation Center facility at MANIT Bhopal, as well as Central Research Facility at MANIT Bhopal. So the two important additions will further enable our researchers and students to actively contribute to national space missions. With focused technical sessions covering research domains across ISRO centers, from VSSC to HSFC, we hope this day will not only inform but also inspire deeper collaboration. Let us together build research bridge that reach new heights, just like our satellites and launch vehicles. Thank you. This is just a formal inauguration, and actual inauguration will be at 2:30, where Chairman ISRO will join us. Thank you.
Good morning to all the dignitaries, experts, faculty members, participants. I welcome you all to the technical sessions 1. I am Yulia Mitra, your host for this technical session. Let's start with our technical session. I am honored to welcome our chair for this technical session, Shri P. Srinivasulu. He is presently Associate Director of the National Remote Sensing Center. He is an expert in geospatial technologies and application with the experience of more than 3 decades. We are also privileged to have with us Dr. K. Dhote, Professor in the Architecture Department and Dean Planning and Development, MANIT Bhopal, as our co-chair for this session. We welcome both of you to this session. Now, let's start with our technical session. We are glad to have with us Ms. Nirupama Tiwari, Deputy Director, Capacity Building and Public Outreach Office of ISRO Headquarters, as our first speaker. She is responsible for the respond activities at ISRO Headquarters. Today, she will be sharing with us the avenues for academia to contribute to Indian space program. Please, ma'am.
Center, URO Satellite Center, Vikram Sarabhai Space Center, Liquid Propulsion System Center, Human Space Flight Center, and so on. So these centers are contributing in all the three areas like space technology, space science, and space applications. There are many sponsored R&D activities under this program. So the one what we will discuss, of course I will be discussing in my upcoming slides. First is like Space Technology Incubation Center. Right now we are in MANIT Bhopal, and this center is for the central region. So we have like these 6 centers in the country. The India is divided into 6 regions. Of course I will be discussing in my upcoming slides. So we have at NIT Agartala, NIT Trichy, NIT Jalandhar, Rourkela, VNIT Nagpur, and NIT Bhopal. Then we have regional academic centers for space. These are also located in the 6 geographical regions of the country, established at NIT Kurukshetra, NIT Patna, NIT Surathkal, IIT BHU Varanasi, MNIT Jaipur, and Guwahati University. Apart from this, we have 9 space technology centers which are established at premier IITs of the country, and the first one was established at ISC Bangalore way back in 1982. Then after that we have established in IIT Madras and Bombay in 1984 and 1985. So our association with academia started around 4 decades ago. Then we have Respond Basket projects which are contributing towards ISRO sponsored research program, and these are for those institutes which are not associated with STCs and RACs. Then we have some academic research centers like Center of Excellence, Center for Nanoscience and Engineering, RAC, and Satish Center for Space Jammu. So first we will discuss about this Space Technology Incubation Center. Geographically, India was divided into 6 regions. So we have, for the northern region, we have at NIT Kurukshetra. It is catering to the states of Jammu and Kashmir, Ladakh, Punjab, Haryana, Chandigarh, Himachal Pradesh, and Uttarakhand. Then we have at central region, where we are here now. It is catering to the research requirements of 3 states, that is Madhya Pradesh, Uttar Pradesh, and Chhattisgarh. Then for the western region, we have it in VNIT Nagpur, and the states covered under that are Rajasthan, Gujarat, Maharashtra, Dadra and Nagar Haveli, Daman and Diu, and Goa. Then in the southern region, the state covers are Karnataka, Kerala, Andhra Pradesh, Telangana, and Tamil Nadu, Puducherry, and Lakshadweep. Then for the eastern region, we have it in NIT Rourkela. The states covered under that Odisha, West Bengal, Sikkim, Jharkhand, Bihar, and Andaman and Nicobar Islands. Then for the northeast, it is covering all the 7 sisters of our country, starting from Arunachal Pradesh, Assam, Meghalaya, Manipur, and Tripura, Nagaland. So what is the basic objective behind STIC is to promote and nurture the young academia to convert their innovative ideas into space-worthy components. So the students are associated with the projects under the guidance of the faculty of these centers, and they work and they use their innovative ideas towards development of critical technologies. Now, what is the main difference between the other center projects and this center project is that here the focus is more towards the technology and process development. Not only research, it leads to some product-oriented outcome which is further tested and validated at ISRO dual centers for its further technology transfer and commercialization. So when the centers were established, these were established in the tier 2 cities where there was no presence of space activities and there was a close proximity to the industrial belt. So the STIC for a particular region, it associates with 8 to 10 colleges of the region. Like if we are talking about central region, the main cell will be in the MANIT Bhopal, but other institutes of the region can collaborate with MANIT Bhopal to come up with more number of projects. And the total budget fixed for this STIC is 2 crores per year. These are some of the ongoing projects. We have around 26 ongoing projects. You can see the distribution, and number of already completed projects are 22. And you can see for the central region, we have only 3 projects. So what I came to understand that there are no projects from the associated colleges. Only these 3 projects are from NIT Bhopal. So there is a requirement that more and more colleges should associate with MANIT Bhopal to carry out the projects. So some of the outcomes, if we see that number of projects developed are 15 and number of students trained 500, patent filed 6 and publications are more than 60 plus. Next, we will talk about regional academic centers for space. This is a regional level initiative. Like the STAC, here also the region, the country is divided into 6 regions. But here it is student centric. The students are given early exposure to the research ecosystem. In this, there are 2 types of projects, short-term projects and long-term projects. The short-term projects are for less than 1 year duration, and the long-term projects are over 1 to 3 years duration. So we have 6 racks in the country. NIT Kurukshetra is for the northern region, MNIT Jaipur is for the western, IIT PHU Varanasi for the central, Guwahati University for the northeastern, NIT Patna for the eastern, and NIT Bristol for the southern region. And these were also established where there was little or less presence of space activities. For RSS also, the budget is limited to 2 crore. But if more and more projects are coming, there is a chance for enhancement of this budget also. So almost RACs and STICs were established during the same time, around 2018. We had our first STIC at NIT Agartala, and the RACs also. The first one was opened at MNIT Jaipur, somewhere in the same time. These are some of the ongoing projects. You can see that we have very less number of projects at Guwahati University. In connection to that, we had arranged a 1-day workshop at Guwahati University, and the response was tremendous. And today morning I met RSS coordinator, and I came to know that around 70 projects they have submitted after the workshop. With that intention, we are organizing it for the central region. Similarly, the one such workshop was organized at NIT Kurukshetra in the month of April. So this I have already explained. So these are the and the DAX and STIC. So these are the space technology cells. Of course, it is not very much relevance here because the projects are submitted from faculty of these IITs, STCs only. We have 9 IITs. The first one, as I told, was established at ISC in 1982. Then Bombay, Madras, Pune, IIT Kharagpur, IIT Kanpur, IIT Roorkee, IIT Guwahati, and IIT Delhi. So these are some of the description of our ongoing projects. You can have a look. So these are old STCs. So number of ongoing projects are more, 205 numbers. And if we talk about outcome from 17 to 24, the total completed projects are 35, and good number of conference and papers have also come out. Now next is the proposals. Submit the proposals. RICS, STIC, they submit the proposal through research areas and space document. This document is biennial, and last time it was released during May 2023, and today we are going to have the next launch. We are going to release this document by ISRO. For this is for the faculty of STCs to apply. For RACs and STIC, OPI is mandatory from the host institute, but for the STCs, since it will be from the faculty of the same college, so there is no associating institute, and OPI will be from STCs. So when the PA applies, his age should be below 65 years. It should be including the project period. The more on the research and how to submit, Mr. Nishan Kumar will be covering in the upcoming session. Then we have the response basket projects. Even if some associated colleges is not able to submit to RACs or STIC, if they are not associated with these centers, they can submit it through response basket. So, but in response basket, we have already defined our research problems. So the research here is more competitive. Recently, we have released response basket in the year 2024 against 158 research problems. We have got some 2,500 responses. So you can see for 158 problems, the response is 2,500. So people are committing to get the projects, and these are the urgent research requirements, and we have already defined the problems. The book was recently released at IST Valimala during ISRO Academia Day 2024, the month of December. Inside the basket, our proposal project requirement is given, title of the problem is given, area of research is given, and to which ISRO dual center belongs is given, and the detail of OPI is given, like his email ID or the contact address. Brief summary is provided, scope and what will be the linkages, deliverables will be provided. So over the past 1 decade, some 330 projects have been completed and 550 JRFs have been submitted. Like now, who can apply under response basket? Faculty of non-STCs, non-RICS institutions can apply. Even if your college is not associated with STIC, you can come through this mode also to submit the research problems. And how to apply is, we have one portal, ISRO Granting Aid for Sponsored Research Program. So through that portal only we need to apply. And this I have already told. And last date of submission is already over, February 2025. But this is an annual document, and this year document will be tentatively released somewhere in the month of December. So here also all areas are covered, broadly space science, space technology and space applications. And if you see sub-area wise also, it is catering to all the important research requirements. These are some of the project outcomes. So I have listed down very few, but it is not limited to this only. Like if we say for since today is STIC workshop, so first I'll mention about online pollution meter. This is the online pollution meter which is developed by our first STIC, opened at NIT Agartala. This device is less than 1 kg, and it is a single device which is catering for the measurement of sulfur oxide, nitrogen oxide, particulate matter 2.5, particulate matter 1, and ozone, methane, and so on. So this technology has been successfully developed, and it is the process of technology transfer. Then if we talk about the other 3 inputs are also from STIC only, like metamaterial based antenna, ferrite based microstrip isolator, carbide adapter. Then we have some good outputs from our STC cell also, like we have the professor IIT Madras. He has developed low temperature gas generator for Blue module upright system. So this has been flight optimized and it is planned to be used in the upcoming Gaganyaan mission. Then this batch reactor, if you see, is developed by IISc. It is calculating or it is defining the efficiency of the monopropellant and it is effective for the use in the thrusters. Similarly, we have good projects from Respond also, like in collaboration with ISRO Inertial System Unit, one professor from our National Institute, he has developed the automatic speech recognition.
Thank you, Nirupama, for briefly stating the entire framework that is available from various project categories and the budget limitations, and also giving a brief outline of already completed projects. Thank you. And I invite Santosh Kumar from BSSC to present the research areas.
design development of the launch vehicle. So launch vehicle is being developed by ISRO with the support of our other systems. So this presentation was supposed to be telling group director, but due to occupation at headquarters, she couldn't come. So on her behalf, I am presenting. So as I said, VSSC is called a temple of technology where there are basically showcases a convergence of multidisciplinary expertise. So I'll just briefly all areas, areas of expertise we have at VSSC, and also show the training area. We are presenting here in our document. Thank you. You can see our basic activities are classified into these different entities. So you have our aeronautics entity where we deal with the mission time, the trajectories for all are made by this aeronautics. And we have ordnance system. So you are launch vehicle with a lot of separation during itself. This is done by ordnance system where we have a test system. Have different separation systems, and the electronics parts of the launch vehicle is also at VSSC, where we have a GC software telemetry system, and we have our control and system is also there, where we do all the simulation before a launch and see that everything is in place. And we have a dedicated facility where we make composite structure for the we have a dedicated materials and metal facility where a lot of activities are happening in materials and and we have all the things being integrated and making the launch ready for the then we have a dedicated polymer chemicals where they with coatings and a lot of research is happening in this area. We have a structural engineering area where we are testing dynamic and the solid propulsion also we have a dedicated facility for the solid propulsion system. And to ensure that all these are working smoothly, we have a structural regulator also which takes care of all and all other regulatory and also we have a management system. I belong to the management system area where technology management, resource management, capacity building, outreach, all these things are system. VSSC also have a space physics lab where we do atmospheric research. So this is all about the basic technology that is available in VSSC. So nowadays the VSSC is called an you cannot find what a lot of technology is happening in that campus at Trivandrum. Just give you a brief about our vehicle and demonstrators. So activity with the sounding that still research areas in longitudinal and space is mainly the space tourism. We have now a lot of we are having our Bharati Antariksh Station, so a lot of activities pertaining to in-orbit servicing, space robotics. Then for recovery we have ground nets. Then we are having a lot of research in green and hybrid propulsion. Then additive manufacturing, and we have AI, intelligent vehicle health monitoring. So all these researches are progressing in a good deal at BSS. Then for achieving all these, we are having our own program called Technology Development Program. So it carries a lot of weightage in our thing because everybody, in almost everybody, every entity will be having their activities in technology development. So we have ongoing around 916 projects, which out of which 214 was started last year. So every year we have a lot of TDPs coming up, and the outcomes are being discussed. And these are, I must say that these are all TDPs are only culminating into projects and all. And so all our R&D, major amenities of R&D are TDP. We have our advanced R&D, also the sponsor research. For the for all technology we need, we have during our reviews whenever we need technology, so we check technologies that are done in house through the form of TDPs and ARDs, and we also see which all technologies has to be taken to the academia. So especially wherever there are a lot of theoretical aspects involved, and we see that and we look forward to academia for such things. We have had a lot of like stories from the academia. So whatever ISRO has achieved today, should be attributed to the academia. Because so this is the city-wise breakup of the TDPs that we have. So this I have not the covered. So I'll just we have 4 platforms to which we have academia. And in USSC we have ongoing projects under base academia. As the Roma said, we are having 39 running projects with 27 space technologies. We have 9. Then regional academic centers, we have 8 run projects with 3 institutions. And STIC, we have 2 projects with all. And these are the few through we are having our ongoing projects. And we are not having any project from MANIT. After this function, we will be getting more projects from this area. I'll quickly show the projects under our various disciplines. Now coming to my presentation, actually research areas, we have 51 research titles, and these are the wise the 51 research titles which we have given in the space document, which we will be releasing today. So just please those research areas. All these research areas are defined and documented in the document we will release today. And all is free to call us. Actually, I am responsible for the research activities of BSS. My contact number is available in the document. So any institute is having any clarification or apprehensions, feel free to contact me. And we are having a program for So I'll just quickly go through these areas that are all the first is in aerodynamics. So we are the first thing is the high RTD simulation of combustible flows. So we are having our house CFD solo called Prava. So this is meant and it will be a linkage to the program linkage to this is the reintegration. We have a dedicated wind tunnel facility. We are having a wind tunnel plus the Trisonic wind tunnel which was recently commenced. So next is mainly in area. The second is the development of a BOS background tolerance system for use in Trisonic wind tunnel. And then again for Trisonic wind tunnel we are looking for development of a forced roll dynamic brake of Trisonic wind tunnel. Then we also another the third to specify the size and shape of boundaries of wind tunnel models. So low angle aerodynamic. Then for Raha we have to area that is the software for three-dimensional motion generation. Also the development and integration of DDEs, that is delayed detached eddy simulation and wall model simulation. These are meant for it's an internal software. So we want to add some modules to that. For that, then next area is the experiment with structural interaction study, understand the parachute dynamics, and then the next the aerodynamic small aspect ratio in body configuration in ground. Next again in aero we have the more heavier for the hybrid motor which we are doing as research to develop a motor. We want support from academy in this area. Next is on aerothermal, we have to design and development of a graphite strip heater to operate the temperature above 3000 degrees Celsius. Then we want to investigation of dynamic stability for entry modules. Then next journal, the development of a measurement technique measurement. Yes, sir. Well, this is in a mechanism to have a question-based penetration mechanism. This is mainly sample return mission. So, then the next four areas in avionics, where is having some microprocessor for the common verification, and you have a lots of a platform computers. Then next is the development of a laser. Then we want a system based on graphene. Then again we want to have a wide putting and receiving antenna. Then next area we want to have a superconductor based electromagnetic field for in the same area we want to have a two proposal with two applications. Then next is a fully distributed Ethernet protocol for inter-processor communication. So in control system analysis of the based control design, focus on technique for memo system. They are looking for autonomous navigation system for precise landing in apps. Guidance and control design for a non-linear framework. After the translation of transport dynamics. Then we are also have energy area, and we are looking for a silicon nanowire infused graphite nanomaterial for high energy density battery system. And I think I'm in the materials and energy department. We have two areas under which can have good thermal non-isogenic NIPU based viable coating for these applications. The range of lattice coating, then the reverse osmosis and habitats. We are looking forward for that is ammonium dinitride, which is characterized for monoplan. Then the theoretical model of cracking reaction and for a scramjet combustion and energy meteorology. So we want to
Details that is available in the job speed.
I'll just and these are some of the services we are having in our space area, and structure also we are looking forward for we also have an in-house base, but for east there also we look forward for academic support for developing more and more modules in that. So that's all. So though I have just to all these things, if you are aware, you can feel free to and we'll be there for you. And we are looking forward for research proposals in these areas from MA. Thank you.
Thank you, Satish. This talk
Thank you for sharing those details with us. The gentle request that speakers please maintain time limit. Our next speaker is Shri P. a science engineer, evaluation group of liquid ocean center in Valiyamal, Thiruvananthapuram, Kerala. I request him to share his vital knowledge on research areas of please, sir.
respected sir, dear faculties and students from various institutions. My name is Srijit. I am representing ISRO LPSC Thiruvananthapuram. So my aim is to give research areas in space or liquid systems. So for that I just tell what is space is for ISRO. So our responsibility area of space science is to design and development of the rockets, liquid propulsion. Basically, propulsion is only taking the satellite to space. So for that, developing ISRO is so many launch ways. So as we have started with sounding rockets. Now we are CSLV, GSLV, and other Mark 3 upcoming vehicle engine. So this system we have different which includes type of categories, which includes earth storable propellants and cryogenic propellants and the dogs methane. And all those things are dealt up the our LPSC. So LPSC's role is that design and development of this liquid propulsion systems for the launch vehicle part. And of course, in the satellite part also there is some propulsion system which will make the satellite in orbit and to raise the orbit from one orbit to. Other than that, LPSC is dealing with the sensor development. Basically, sensor is the amount of a launch vehicle or a satellite. So our LPSC is dealing with the sensors. Basically, sensor means pressure, temperature, heat flux, and all those parameters that we have to measure. So this is our LPSC's main role
if you take the launch vehicles of ISRO, if you take PSLV, PSLV is a vehicle. So all the stages are in different stages. So our LPS's role is to develop the stages for this launch vehicle. So PSLV we have solid and stages involved a PS stage, second stage, which has a bigger stage that is developed our LPSC, and that entire part of second stage of PSL. PS4 is the fourth stage of PSL. So similar to that, we have the another vehicle GSL, which is a training stage. So the second stage is GS2 with the another stage which is the cryogenic stage. Cryogenic is nothing but the low temperature liquid oxygen and liquid hydrogen are used for the propulsion of the particular stage. Other than that, we have our heavier launch vehicle LVM-3. There also we have a twin gas engine L1 stage and one cryogenic stage, which is the indigenously developed one. So the same vehicle recently we have upgraded for human rated for the human mission also. So another vehicle is SSLV. SSLV is actually a solid stage vehicle, but still there is a liquid stage at the top which is called velocity training module to precise injection of the satellite into the orbit. So that also developed by our LPSC. So we are in the verge of developing advanced vehicle with the more payload carrying capacity. For that, we are developing a new engine which is called a semi-cryogenic engine and an upgraded cryogenic engine. So using these two, we can replace or enhance the payload capability of our present LVM-3 vehicle, that is 4 ton, to another 1 ton, that is 5 ton, by replacing these two. For that, we are developing a semi-cryogenic engine. So semi-cryo means we are using a cryogenic propellant, which is the liquid oxygen, and along with that, the fuel is the ISRO developed kerosene, which is called ISRO. So these engine and stage are being developed at LPSC. So using this LVM-3 in the human rated condition, we can take a human from Earth to orbit, which is the product name you may be aware is called a Gaganyaan project. So if you take a Gaganyaan launch vehicle or the vehicle which is taking human from Earth to orbit, we are developing the liquid stage for this launch vehicle, which includes the human rated L1. That means already L1 is developed that has been human rated with extra safety aspects and redundancy. That is the L1 human rated stage, and the cryogenic stage, which is the presently this 32 ton stage, C32 stage. Other than that, in the module also, the crew module, we have that crew module propulsion system. Basically, the liquid part of the liquid propulsion system part is there in the crew module. Other than that, in the service module also, these things are there. In addition to that, since we are dealing with the liquid propulsion, we are dealing with a lot of control components. Basically, the basic difference is that we can control the flow of the fluid. For that, we are developing a lot of control components. So all these control components, we can use it for our cabin pressure control system of the Gaganyaan crew module also. So this we have used in our test vehicle, which is to test the crew escape system, where we have used the launch vehicle with our gas engine, upgraded gas engine, that is called a test vehicle that we already demonstrated. And if you take this total Gaganyaan deliverables, we have that all these systems along with that thermal and conditional levels, that is also part of control. Other than that, we have a lot of sensors for this So all these are about the launch vehicle. So this is our spacecraft propulsion. Basically, a spacecraft is orbiting around the Earth, but we need to keep the satellite in position, and we have to keep the space. The satellite should be in a particular orbit for a long period. For that, we need some propulsion system. That propulsion systems are being also worked by LPSC. We are using a monopropellant system or bipropellant system, and both cases, geosat and Earth observation system, we are using this. So these are all the major avenues of LPSC activities in ISRO. So I will just mention some of the major contributions for LPSC in the scientific missions like Chandrayaan 1 on Mars orbital mission and the Chandrayaan 2. As you are aware, after launching the satellite, launch vehicle is the must, and for that LPSC deliver order. And for the lander system, for the spacecraft to reach on the surface of Moon, also we have developed a unique propulsion system which only made the satellite to launch on the surface of the Moon, and a similar one we are adopted in the Mars orbital mission. There also we are using a small engines which is called a liquid apogee motor that only fire this engine after a long period to reach the Mars orbit, or in the case of Chandrayaan also. So Chandrayaan 3 also is the same system, so we have used including the launch vehicle, all the propulsion systems, everything we already LPSC only developed. So other one is the Aditya L1 mission. There also PSLV is the launch vehicle we have used, and the propulsion system in the sense that the satellite has some LAM engines and thrusters of 22 newtons for the precise orbit insertion of the satellite. So this is another one, which is the SPADEX mission, which is required for the future missions of ISRO, the docking of satellites. There also LPSC delivered propulsion systems are played a crucial role. Both the docking and undocking has been completed recently. So other than the chemical propulsion system, what I told earlier, we are developing another system which is called electric propulsion system. So basically, instead of chemical energy, we are using a electric stationary plasma thruster to develop a long ISP, or it is called ISP. ISP is more for this electric propulsion. For that, we are making a satellite. This system we can use in satellite. So we are on the job of developing a electric propulsion satellite in the future, which is having a thrust of 300 million. So this activity also being taken place at the LPSC. So other than this one is the development of sensors. Basically, earlier we are using the sensors from outside. Now we are on the job of indigenizing the sensors for our own applications, which involves indigenization of various sensors like temperature, pressure, level sensor, all those things. So this is the sensor development for the propulsion system. So in a nutshell, if I say LPSC's deliverables is for the development of launch vehicle, we are making the stages of engines of various capacities, starting from 1 millinewton thrust level to that 2000 kilonewton semi-cryogenic engine, and the next another development is the development of a LOX methane engine that also being developed, that is coming in the NGLD. And using these engines, we are making different stages for the launch vehicle. That only we are seeing as a PSLV or GSLV or NGLV. So just one slide about the future missions, which includes the development of a new launch vehicle for carrying more payload, and the Bharati Antariksh Station for our own space station. There are also propulsion systems there. For launching that also we need liquid propulsion system. And the Chandrayaan sample return mission, like in Chandrayaan 3 and 2, we need a propulsion system for the precise landing and taking samples from the Moon. And the Venus orbital mission, there are also propulsion system for our liquid propulsion system is required. So this is what I told about the NGLV. NGLV is basically a pure liquid launch vehicle because it uses liquid oxygen and liquid methane. So we have 3 stages, and all those 3 stages we made it or designed it in such a way that it will carry the satellite from Earth to orbit, and the load carrying capacity is also more. Here we are passing more number of 9 numbers of low speed engine. So the engine is also being developed, and once it is developed, we will cluster it and we will use it in our next generation launch vehicle. So for that, technology demonstration, that means liquid oxygen and methane combination propellant and different catalysts has been completed, and that can make the liquid methane engine. So this is the Chandrayaan 4 contributions. We have different small cost engines for each modules. It is 5 modules. So each module for LPSC deliverables are there. Similarly, the Bharati Antariksha Station also different modules. We have propulsion system and associated propulsion system related things. So all these are part of LPSC delivery. So now I will tell about the research areas for doing all this activity. Now you got an idea about LPSC's role in Indian space program. Whatever launch vehicle we take, everywhere LPSC is there. So now our aim is to make this is very similar or to innovative way. For that only we are collaborating with the academia for different research and development activities. So we have some in-house R&D PDP activities which are around 157 area projects are ongoing. So each team is every team is concentrating on different development areas. Other than that, we have academic interfaces with various institutions within India, which includes various IITs and NITs on all those things. So I will just give half of my presentation for this. So our LPSC research areas are basically, as I told, we are dealing with the liquid propulsion. So liquid propulsion is the major crux of our research area. Other than that, electric propulsion is there, and everywhere we need the manufacturing and materials related technologies. Because if you take the new launch vehicle, the new engine, it is an entirely new engine, not procured from anywhere. We are starting from scratch. For that, we need to develop our own materials. We need to make 3D printing technologies, and different technologies are involved in the material development. Other than that, the transducers and sensors, that is already developed, but that has to be number quantities will be more in this area. Other than that, the design and analysis area. So for that, we have different, as Madam told, different approaches we are adopting for the sponsored research. In that, we have response basket and research areas for science and IST human link, all those things are there. That I will just tell. So for the LPSC academic interface, we have 149 projects as of now. So out of that, majority are the space technology cell activities. Presently 24 projects are ongoing activities are there. So that details I will just cover. These are the 24 areas of projects which is taken by different IITs. ISC Bangalore, that Madam told. So we are having 24 projects there at 7 institutions within India. Other than that, RIC space project, we have materials related, because our LPS is making different materials for space applications and launch vehicle, especially the semi-cryo engine development time. We need a lot of materials related activities. For that, we have NIT institutions for making the materials for these areas. So as Santosh told, we are also having the research areas in space, which as I told, there are 6 areas. Mainly it is focusing on liquid propulsion. Liquid propulsion means it involves development of the propulsion system and the enhancements of existing systems. So these are all the major things. In my own reading, the details are available in the research activities booklet today we are going to release. Basically, this comes under liquid propulsion system, which can be used in various upcoming linkage with a lot of projects.
You conclude.
Okay. And other one is the advanced propulsion system and control electronics. As I told, materials area also we have different developments. Other than that, sensors and the analysis area, non-destructive system area. And this is the response basket. I think there are 12 projects personally there, 9 institutions are involved. These are the areas involved, propulsion and power sensors. Basically 16 areas are identified for this response basket. Other than that, we have the AAC mission specific project with CNSC, and 2 Yukti Sandhya projects are from this institute. Actually, it is the development of miniature pressure transducers and ultrasound transducers. So like that, we are expecting more from this area. And we have IAC. IAC is very near to our office. They are doing some of the projects which is linked to our future projects with respect to electric propulsion and the other propulsion areas of LPSC. So other than this, the small projects, 5 projects are there. 4 institutions are presently involved in this. So this is the summary of our ongoing research collaboration with academia. So out of that, from this institute, we have 2 center projects. Other than that, basically different response basket we are having proposal. So this is the portfolio of BSc for research. Thank you, sir. Thank you.
Thank you, Sujit, for being the overview of PSC and also a glimpse of different propulsion systems and the scope available for research. Thank you.
Thank you, sir, for your valuable knowledge. Now, as we reach to the last technical talk of the session, I would request Sri KVS Bhaskar, Program Director of UR Rao Satellite Center, Bangalore. He will be discussing research areas of URSC. Please, sir, start with your presentation.
Bhaskar, since we overshot time, I would request you to say something. Thank you.
My name is Bhaskar and I am the program director for user-funded program office, wherein we deal with both LEO and geostationary satellite applications for commercial users, strategic users like Navy, Air Force, Army, and special users like DRDO. I'm extremely happy to be a part of this central region, and I would like to thank CBPO director and his team for taking this initiative. As all of you know, space is multidimensional, and there are actually 4 aspects to this space infrastructure. Basically, the 4 phases of satellite are one is the societal applications, which all of us know, and in the areas of telecommunication, broadcasting, including TV and radio, news gathering, internet, and multimedia, such as meteorology and navigation. The other aspect is the prolongation of space science research and the area of atmospheric research, interplanetary missions, and also once we have this large data, we need to handle them and disseminate it. So for this, we have the national resource management, national resource systems, and special needs. Apart from this, we have the social effective utilization for socio-economic development. We have to enhance the strategic technology capabilities, and we have to leverage this for international cooperation. Apart from making effective policies and frameworks. So these all the 3 things are the 3 vertices of this triangle, wherein currently ISRO is providing the space infrastructure and doing all these activities. But considering the vast application of satellites and the users, I think industries and academia need to step in. Also, there are a lot of technology developments, for which I think it is very imperative that academia should participate, as all the research cannot be done by ISRO alone. Yes. Apart from this satellite program, also there are many dimensions. We have a bouquet of satellites ranging from the high altitude communication satellite to low Earth orbits. On the left side, what you are seeing is satellites from which we do it from geostationary orbit up to 6,000 kilometers. Earlier, we had the first generation INSAT-1 series, wherein the launchers from abroad, and subsequently, once we had our own launchers, we had the research series of communication satellites, which are used for telecom applications, meteorology, and broadcasting. And coming to the
we have images at any point of time of any part of the globe. We have the remote sensing both in the optical domain and the RF domain. The cartosats are the map making and the ocean remote sensing are in the optical domain, whereas the RF satellites are the radio imaging satellites dealing with SAR applications. Apart from this, we have the scientific applications wherein AstroSat is one of all these are launched. AstroSat is for astronomical satellite. Chandrayaan, as all of you know, is with dealing with lunar related research. Aditya was the recent solar studies, and Megatropics is the climatological. Megatropics deals with the climatological studies of the Earth. And all these are comes under the category of application specific missions. Apart from this, whenever we want to experiment on new technologies, especially for these new technologies under the category of experimental satellite, there is DSAT-2 and spacecraft record experiment DSAT-4 all dealt with different areas of satellite technologies, wherein we first do these technologies and then subsequently operationalize this and operational satellite. Apart from this, there is another aspect which is the navigation thing. Herein we have our own regional navigation satellite, constellation of 7 satellites covering 1,500 kilometers around India and surrounding areas. And this is augmented by weapon, that is the GPS aided navigation system. With this, we can find out our position and time anywhere, any time. And currently, we are proud to say that we are able to give it less than 5 meters. All the satellites are designed, developed, and realized in-house at URSC. And also the project management, R&D of all these satellites are done at the URSC Satellite Center. Next, coming to this academic research and outreach, as you all know, our founder, Professor Rao had initiated this research activities to academia also, and he was the guiding spirit for our center. And through this program, many of our ISRO staff have been sponsored for higher studies like chemical programs in all major leading institutions. Also, recently, URSC has recognized the VTU as a research center, enabling our staff to register as research students and also as supervisors to guide the research students. Several patents, series have been flourishing in these technological areas in the center. Also, like earlier, Madam was telling, we have this response basket and STC cells, which we had enumerated earlier. Currently, the good outcome of this is several institutes have already made their own satellites, which we have launched for them. Some of these are listed in this slide. There are basically ANUSAT from Anna University, SRM-SAT from SRM University, IIT Kanpur, ISRO, and there are many other satellites from Bangalore itself, from the local universities like PES. And also we had given support to this foreign university satellites also, like the University of Colorado SAT. Also, another more consortium of 7 engineering colleges, Bangalore and Hyderabad, also we had the student satellite. This what I want to convey this slide is even institutions can develop their own satellites. Next, this is another major initiative which now we are taking to the colleges. This is basically ISRO, standing for ISRO Rover Challenge, and this has been started last year. This thing, and it was held during the throughout the year, wherein we had around 150 colleges participating from various places. Basically, the boundary conditions of the rover have been designed, as you can see in the right hand corner. We define the specifications of the rover. Then we ask students to think how to do these applications. Basically, this calls for some fundamental applications of maths, science, and other innovative techniques. Out of this, 148 techniques, 90 had qualified for the next round, from which we had selected 20, and finally 10 rovers have been selected. All these 10 rovers have been showcased at New Delhi on National Science Fair, which was held on August 4. The good thing was Honorable President of India has illustrated all these 10 winning rovers. And another thing is that this year too we have made another, we are putting IROC 225, wherein we are asking students to design an aerial vehicle which will have a projected usage for Mars. Next, coming to the satellite system, there are several subsystems. It is basically a complex engineering system of complex subsystems. And the topmost, we have a payload which defines the purpose of the spacecraft. To support this payload functioning, we have the power systems, data handling systems, control systems for giving the required quantity, mechanism for deploying antennas and solar panels, and for maintaining the temperature of various spacecraft systems. We have thermal management systems, and to do the day-to-day functioning and handling the contingencies, we have the onboard computer system, and for lifting the satellite to the intended orbit, we have the non-vehicle interface. Here there is what I want to indicate with this slide is there are multidisciplinary activities, and any area of free branch of engineering or fundamental science has scope in the satellite system. Next, we have a very bouquet of satellites starting from the under 1 kilo, that is 0.8 kilos of the student satellite, down to the topmost 10,000 satellites. And these are made by ISRO and several agencies which we have launched. Basically, the guidelines for developing all these satellites have been given in NASA Technology Handbook, wherein all the guidelines, interfaces, required processes and other components which have been defined. This also serves as a baseline for all these satellite activities. This is available readily in the public domain in the NASA website. Apart from this, ISRO also that going to start a release guidelines of how to go about the processes and activities. Next, basically, this slide shows a totally different picture. Where it is called Academia to Silicon Valley concept. Unlike what people imagine that the people very forced in very highly clean rooms, what we see is young students in jeans and t-shirts. They themselves are also developing the satellites. The slide basically shows a Planet Lab incorporation, which designs and manufactures 3D pictures called clouds that provide an imaging at the climate optimal resolution. It looks lower like a supermarket with a lot of satellites, where you are seeing charges, CubeSats which are placed, and which have been launched recently. So it will not be the purview of very high-end capital intensive things. Even students can do it with some nominal budget, which will be happy to support. Next, I just briefly listed out what are all the technologies which are required for spacecraft development, and it's also been given in our road to mission 2035 to 2027, which is 100 years of our experiment. Basically, what we are looking for is things which can be assembled in space, and modular spacecraft architectures to facilitate on-orbit assembly and repair. As you know, satellite is a very costly business. So what we require is something like our tow truck which repairs vehicles on the road, such sort of modular structures wherein a particular subsystem can be specifically removed and factored in space itself. Then there is a large scope for robotics, tele-robotics and autonomous systems using artificial intelligence and machine languages. Apart from this, the traditional communication, navigation and data related services are from a new orbit, which is a medium orbit. Then apart from this, like our previous speakers have mentioned, there are a lot of interplanetary and landing missions. So this calls for entry, descent and a lot of other gear which is required for successful completion of your mission. Apart from this, for this astronomical applications, we require scientific instruments and many high-end detectors and sensor systems. Apart from this, we require large space structures, materials, components, thermal management, additive manufacturing, which is the buzzword today. And for all this, we require comprehensive modeling, simulation, information technology, and processing. And once the infrastructure is in place, we also require a terrestrial ground support system for processing and validation of all this support techniques. Then the other most important is the irrigation activities. Basically, a good amount of solar components are stored across piece of our valuable foreign exchange. Towards this, a lot of trust is given to engineering of components. Basically, these are the HMC, which is hybrid with micro circuits, application specific circuits, and DC-DC converters for power. And also, as space is a very risky business, the processes have to be very tightly controlled, for which we require special analyzing, coding, lubrication. Apart from this, materials have to withstand the harsh environments of space, which calls for dedicated alloys, paints, chemicals, etc. And as mentioned, satellite, electrical, mechanical, and ground system support also have to be accommodated. So for all this, a good amount of R&D, research, and economic collaboration, apart from industrial support, is necessary for the future outcome. Then I just wanted to show a small case study wherein this academic research outfit has And apart from this, there were more than around 160 publications made from this academia research outreach itself. And apart from this, recently we have the Aditya, where we have a lot of planetary science data, and I have given a list of the contact persons below. People can do this. This data is available in the public domain also, and people can contact the persons below if they are interested in doing this. Thank you for the
Thank you, Bhaskar. Your concluding slide was also on Bhaskar. Satellite is complex, has a lot of complex subsystems. I think this is more fertile ground for a lot of research activity. Thank you. I think we completed. We had 4 presentations. One dealing with overview of overall framework and the facilities available from ISRO, followed by 3 centers, DSCC, LDSC and NYSC, on broad scope of research areas. The document that is planned to be released will be more details. I was just trying to explain because we want to spill over into the inaugural session, which is fixed right there, session. So I conclude this session, and I thank my co-chair, Dr. Jyoti, and thank you very much.
This was our last technical talk for this session. I am thankful and grateful to our chair and co-chair along with all the speakers. Now we will have a short tea break, a short high tea, and for that you will be having only 15 minutes, and you have to be back here at sharp 10:45. Since 11:45, since we have other technical sessions in night, you can get straight out from here and then the venue is there. Okay, thank you.
My ISRO colleagues are telling me that if you have any questions that you can ask them during the discussion session as a first year. Please.
सर क्या है मैं हमेशा मैं हमेशा ही 5 मिनट पहले बोलने के बाद मतलब कोई मैं नहीं करता, काउंट ही नहीं करता, तो मैंने क्या वो तो करेगा मेमोरी सिस्टम थोड़ा अलग है चीज़ अगर सीखने को मिल चलो आप ये भी भूल जाएंगे कि 5 मिनट बाद 5 मिनट करेंगे तो गया आप बैठ जा 1 साल के बाद चल रहा है हम पूरे आ गए होंगे पूरे के साथ साथ आवाज़ भी जाए हाँ वही होती है हाँ किसी का नाम नहीं है अच्छा सुधीर सर बैठिए नहीं बंद कर लाइट बाथरूम
of ISRO. I request you, sir, please come here and present your speech.
Good morning to all. I am Pradeep Kumar from Radar Development Area ISRO. I am presenting the ISRO Telemetry Tracking and Command Network research areas. So if you see about our ISRO activities, mainly we are vertically divided into around some 7 areas and working on TTC systems, telemetry tracking and commanding systems for launch vehicle and satellite missions and applications. Mainly, this is precisely meant for that track space objects precisely and receive telemetry data for health and status monitoring, and send commands for the mission control and reconfiguration applications. And also, this we are extended from the TTCs to the launch vehicles to the satellite missions, and we are working on, already we are supporting for the LEO and interplanetary mission controls and operation systems, mainly for the Chandrayaan applications or Mars missions applications and all. And apart from it, we have a third vertical is in the NAVIC ground segment research. It is mainly focuses on the enhancing the performance of ground monitoring stations. Yes, sorry, right. And the third vertical, what I was saying is that ground segment in research, and really for the focusing on of the performance of ground monitoring stations, improving real-time orbit clock estimation algorithms, and developing advanced error correction and signal quality assessment techniques. This is the third vertical, and apart from it, from past 2 years, we have started working on space situational awareness. Is mainly meant for that LEO, GEO, and NEO-based orbits detection of the space objects, and avoiding mainly for the congestions of safeguarding of space assets. And the fifth vertical is radar systems research. Under this, we are working on atmospheric and weather radar research, like developing the ground sensors for the Doppler weather radar systems and wind profiling radars. And then we are working for this objects detections and tracking and cataloging kind of systems. And another vertical is for the science data archivals and disseminations to the researchers, and search and rescue disaster management applications, mainly the LEOSAR and MEOSAR based applications. Under this, if we sort TTC based ground segment systems, we have a footprint of only around more than some 30 to 40 ground station systems are available, mainly spanning from the VHF to VHF, UHF, L-band, S-band, C-band, X-band, and Ka-band based communication systems. And for the interplanetary systems, we are using D32, 32 meter based dish antenna systems to communicate interplanetary communication systems. And at present, in this area, we are having a lot of other research, and we are augmenting our current existing deep space network based systems with network of the DSNS and distributed arrays with a small network, flow-based distributed antenna array systems. These are the areas we are working mainly for developing the algorithms for antenna array signal algorithms and arrays, and occasional algorithms for signal processing deep space network, and also calculating and challenges in DSN and array systems. So these are the areas open this research proposals what we are submitted as of now. And the next NAVIC ground segment research point of, we are having a global footprint, precise ranging and time point of view. Under this articles, we are project areas, mainly atomic clock navigations related technologies, mainly Trojan measures and frequency synthesizers for active hydrogen electronics development of the systems. Apart from antenna and RF systems for development of the antennas for L1, L2, L5, and S-band antennas and C-band antenna feed system areas we have projected in this research proposals. And the third one, space object surveillance and tracking and imaging systems. This, as mentioned previously, we are mainly supporting for the different launch missions of the radar systems, which can track and missions wise, go to that atmospheric and other research applications of the radar. A lot of research are open in this domain, mainly on the signals and products development of view, to hand over this data sets to the physical department's point. And this data is available at SAC, most DAC web application. And then tracking radar systems. So we are having a of research proposals we are added into the inverse synthetic aperture radar systems signal processing for space domain. And if you see that current technologies with chip solutions, which digitize up to 64 gigahertz a second with a current of 30 gigahertz, 35 frequencies. So we are establishing a based digital beamformer imaging radar system, inverse systems, mainly to address two-dimensional and three-dimensional imaging wise. There's a lot of process wise research are there in these proposals, and also a MIMO and cognitive-based space debris signal problems and operational algorithms wise, mainly to conventional dense array to space to minimize the total capacity of the systems. Normal dense antenna arrays for the long locations, it will be spanning more than some type of antenna elements, digitizing every element. So those optimize to maintain the width, to bring down resolutions, to improve and require raised lobes to suppress and all the things. Openings are there in the MIMO systems point of view, and mainly for radar waveform generations, other waveform systems wise, and systems calibrations in the MIMO based projected into the system proposals. Apart from the radars, working on telescopes, these space objects, we are established multiple telescopes network, and in domain optical imaging research is also the space detect calculations in optical domain, and space objects characterization, remote sensing, data mining, and daytime observations of the space telescopes, and space-based sensors towards space-based for the NEO threat missions purpose. So here also is a lot of research studies. It is open a lot of the research on this. These are the broadly what we are working out as of open for the research activities. Thank you.
Ma'am, and question you can ask.
Thank you for and areas in which track is I wish we'll be having a number of projects on certain mission and vehicle. And yes, thank you so much.
Thank you.
Basically, it was a nice presentation showcasing this track. What means to is that it is a situational analysis, because the low Earth orbit is proliferated with the constellations. So the good amount of work which needs to be distracted. So I think that's a very potential area of research.
Thank you.
Thank you, sir, for sharing your vital knowledge. The audience has a question in the presentation. You could ask it in the after the session. Now, our second speaker is Shri Kesh Desai. He is the head of space applications. He will be sharing information related to research areas of SSC. I request you to kindly start your presentation.
कर गया मैं
Good afternoon. My name is Vulkesh Desai. I am a group head at Microwave Mechanical at SAC. First of all, I would like to thank for arranging this ISRO Industry Academy meet. I would like to thank Center Director Nilesh Desai, who has nominated me to come here technologies which have been done at this application center. I also opportunity to thank all the deputy directors who have been responsible in or helping me in presentation. As you know, ISRO is a very unique and within a unique organization like ISRO, Space Application Center is another unique organization which has both the applications part. All being developed at SAC are application driven. Means all the applications are our main goal, and on the applications, the specifications for the payloads are derived, and that's an evaluation of how the payloads are done. So for the payload is primarily divided into communication, navigation, optical in the microwave remote sensing area. Similarly, in the application domain, we have applications of the communication system, navigation system as a remote sensing. The tax humans is very, having very wide background, starting from mechanical engineering to electronics, biological science, physical science, chemical science, and geological science. This which we take at SAC, go the technology development, the development, realization, application development, software development, that is all the data products are related at SAC. Then technology transfer of the technology which we have developed in-house. We have more than 100 plus technologies have been transferred to the industries. More than 90 plus payloads have been designed and realized at SAC. We have 100 partners, partners being industries, MSMEs, industry, academia, and international agencies like JP and KNS. This shows the verticals we have at Space Services Center, starting from the SATCOM and which are responsible for the development of GSAT navigation satellites. Microwave sensor technology, area which develop microwave remote sensing sensors, synthetic aperture radars, scatometer, ground penetrating radars, etc. Electro-optical laser sensor technology. The electro-optical sensor consists of both the development of the sensor as the development at Cartosat, all the and Chandrayaan orbital high resolution camera, all have been done at this area. Antenna systems encompasses all the other areas because antennas are the basic communication source from a satellite to the ground link. So all the antenna systems related research takes at SAC. Recently, we have also started human spaceflight program. So SAC also has a contribution towards the ECLSS as well as the crew cabin systems for the Gaganyaan project. SATCAM and SAVNA applications, again, as I said, applications and payload go hand in hand at SAC. So we have SATNAV and SATCOM applications area, the Earth observation, planetary science and applications area, which basically looks for the end-use societal applications of the Earth observation satellites. And the backbone of the SAC is the electronics and microelectronic design, mechanical engineering systems, systems reliability, and project management. I'll just briefly touch upon the ISRO's communication satellites which have been done. So we have satellites made from UHF band to QV band to optical band. I've listed the number of names of satellites which are there in the orbit, as well as the navigation payloads from IRNSS 1 series to Navik series, which also has the L1, L5, and S band, and the Gagan, which sir had told about the applications of civil aviation. These are some of the recent payloads which have been flown. The GSAT-24 payload, which is 24 channel direct DTH. Then the GSAT-20 on the right-hand side top, which is one of the HTS satellite, high throughput satellite, which gives 48 plus Gbps throughput. And this is the satellite which is bound to give you in-flight connectivity in Indian region. The IRNSS payload, which has the indigenous atomic clock, is also developed at SAC. The bottom figure which you see is the spectrum monitoring payload. This was an experimental payload which was flown in EOS-07. The current technological engagements and the future are like for systems engineering, it is the LEO-based satellite and communication system design. People are coming from GEO to LEO with having multiple number of satellites, swarm satellites. Then GEO high throughput payload design and simulation. Space-based AIS and ADS-B for air traffic control and for air traffic monitoring. Frequency sharing and frequency sharing satellites. Then in the RF system development, it is about development of GaN-based high-power SSPS, beamforming chip, then high-power QV filters, and integrated digital antennas and systems. For digital systems, it will be a software-defined radio and onboard regeneration HTS. The research areas are primarily focused into reducing the cost per bit. That means developing a lot of high throughput satellites and we are adapting to the changing user demands. That is, we are developing technologies towards making flexible payloads. So flexible in terms of bandwidth, flexible in terms of user coverage. And towards economical ground terminals, that is making portable user equipments. This calls for very very large antennas on the space segment to the tune of 12 to 18 meters, so that the ground terminals can be as small as possible, which can be man-portable. These are some of the critical technologies which have been developed. As I told, the indigenous rubidium atomic clock, which is a step towards Atmanirbhar Bharat, was developed at SAC, and now it is flowing in the recent IRNS series of satellites. And the indigenous KU-band 200-watt DWTs have also been designed and realized at SAC. This has also been flown, and again in TDS-01 it is again going to fly. The bottom image which you see is a terahertz wave telescope. This is planned to be a ground-based observatory, which is planned to be placed at Hanley. It will be having two frequencies, 243 and 345 gigahertz. This will be one of the highest frequencies in which ISRO has ever worked upon, primarily focused on space astronomy. In the antenna domain, the active phase array antennas have been designed for satellite on the move application. This concept basically gives for a very small temperature, and it does not require mechanical steering, since it has an electronic beam steering. Antenna development with gap wave technology. These technologies are used for and for very high frequency antennas. These are some of the SATCOM applications for future initiatives. You can see from mobile satellite services to maritime awareness, all the technologies are required here. SAC has been in the frontier of quantum technology at ISRO. We have already demonstrated quantum key distribution at SAC in 2022, wherein two buildings across ISRO center where quantum key distribution was done, encryption. And now this is scaled down to a future opto-quantum satellite. We are making one opto-quantum payload for the upcoming technology demonstration satellite, which will be having a source on the satellite itself. NAVIC, as you know, it is again the Indian answer to the global GPS. So this is again an Atmanirbhar Bharat initiative which was taken by ISRO 20 years before. This provides civilian standard positioning of around 10 meters, and for strategic users, this positioning can go as to 5 meters. These are some of the innovative NAVIC and GNSS receivers which were designed in space application, and entire technology transfer was given to the Indian industries. More than 10,000 of these terminals are under use at various departments and ministries. And NAVIC-based indigenous chipset have also been designed and realized. These are the images of some of the chipset which have been developed. Some of the mobile phones also have these NAVIC chipsets, and future, in next 5 years down the lane, you will see that all mobiles which are operating in India will have a NAVIC-based chipset. This is again indigenous development of 100-channel NAVIC plus GNSS digital baseband ASIC at 28 nanometer. This was designed at SAC and fabricated at SCL Chandigarh. The technology basically enables NAVIC long code authorized service in a very miniaturized and a low-cost platform. These are some of the short-term, mid-term, and long-term application roadmaps. For the paucity of time, I'll just proceed. This slide shows basically the implementation of the GSAT-6 for the various services of Indian Railways. On the left-hand side, which you see top, is the image where the unmanned level crossing, the GSAT-6 satellite is being used. And the real-time train traffic information which you see, it is because of the GSAT-6 application that you can see that where exactly the trains are right now. For personal tracker also, these technologies have been used. This is primarily towards border tracking. And fishermen stress alert terminals have also been deployed. I think government of Tamil Nadu and government of Kerala have been in forefront of using these Navik Plus MSS based terminals for fishermen. This is what is going to come in future. We will be having NAMCOM for navigation and communication for space and maritime domain awareness. As we see, that is India has a very large sea boundary, so our naval assets have to be protected. For that, we have a maritime domain awareness satellite planned with automatic AIS system for detecting the dark ships, which is very strategically important. In case of micro remote sensing sensors, which started around 35 years ago, we have been into like agriculture and forestry, meteorology, oceanography. These are the many applications for microwave remote sensing. And in terms of hardware, we have gone from megahertz to terahertz. So, like the payloads being spaceborne and airborne synthetic aperture radars, radar altimeter, scatterometer, sounder and radiometer. GNSS reflectivity is the newest in our technologies, and the ground penetrating radar. This slide shows the from 1976, where in the Bhaskara payload, the Samir payload was the one which was flown. It was a 32 gigahertz payload, and from there we have come to 2025, wherein we have the latest NASA ISRO synthetic aperture radar, which will be flowing next month. This is the SAR application which is at SAC, as I told, from 2021, wherein we developed RSAT-1, which was the first indigenous SAR. It's a very critical and it's a very denied technology, and that's the reason why initiative was taken. And more of these, the heart of the satellite is the TR module, transmit receive modules. 7 of the critical MMICs were developed in-house, and they were qualified by a foundry called as GATEC, which comes under DRDO. This is the heaviest EO satellite ever built by ISRO at 1858 kgs, but still it is the lightest in its class world across. In the following mission for the C-band radar, we miniaturized the TR module a little further, which went into an LTCC-based TR module, wherein we could save more than 100 kgs of mass in the entire satellite. And the critical medium power amplifier and the low noise amplifier was again developed in-house. This slide shows about the NASA ISRO synthetic aperture radar, which is the next mission. This is a unique mission which will be flowing both L-band and S-band synthetic aperture radars. L-band is supplied by the JPL NASA, and S-band is developed at SAC Ahmedabad. This is based on a very novel technology called as sweep SAR, or scan on receive concept, which primarily gives a very wide swath and a high resolution. So it has a swath of 250 kilometers with a resolution of 6 meters. One of the key technology driver here was 165 watt GaN-based SSPA development and a digital beamformer. This slide shows about the hardware pictures of the satellite at various stage. These scatterometers are also critical technologies which were developed. This has primarily an ocean application. It measures wind vector and wind velocity. It helps in cyclogenesis as well as cyclone tracking. So what it does is, it basically measures wind vector over the ocean, and by measuring the wind vectors, it provides the cyclogenesis information as well as where the cyclone is going to make a landfall. So because of this satellite, thousands of lives have been saved on the eastern border, wherever now we can track the cyclone and we can predict the cyclone landfall very precisely. The P-band airborne SAR development was also taken up by SAC. This is one of the full polarimetric SAR which was developed, completely developed in India. On the right-hand side top corner, you can see an image between an X-band and a P-band. X-band does not have a depth of penetration, whereas P-band, being a low frequency 450 megahertz, can go under the foliage. So it has an under foliage penetration, and that's how you can see the geometrical features which are under the foliage. So it has a reconnaissance objective also. The GNSS reflectivity payload was again one of the opportunity payloads which we flew in the SSLV D3 mission. It primarily uses the signal of opportunity. What it means is we already have the GPS and NAVIC signals available. So what it does is it basically detects the reflected signal from those NAVIC and GPS signals, and thereby we can predict and we can have a lot of applications like soil moisture study, then land inundation study, ocean wind speed, and significant wave height. This satellite is again in orbit and it is giving valuable data.
Please sum up in 3 minutes, please.
This is about the ground penetrating radar. We have a GPR coming for the LUPEX mission, which will be again a step frequency CW radar. Chandrayaan 3 historic landing was also, we had a very great hand in it. The carbon radar altimeter, which was a prime sensor for autonomous soft landing, was developed at MRSA at SAC. This is the detail about an humidity sounder on EOS 07. It is operating at 183 gigahertz and has a capability of giving humidity profiling up to the troposphere. These are the images of some of the gas MMICs which are designed in-house and realized by industry. And in the electro-optical sensors, we have sensors for land, water, high-resolution ocean and weather climate monitoring. These are some of the images of the optical sensors which were developed at SAC. This is one of the satellites called as OceanSat-3, which also has a 13-band ocean current monitor, which is used for potential fishing zone prediction. These are some of the electro-optical payloads which are there for the future missions, like Cartosat-3A, ResourceSat-3, HRSat, and one of the mission is going to be a Trishna, which is an ISRO-CNES joint program, CNSS-ESA. And this will be having 2 SWIR detectors, SWIR-based cameras on board. These are some of the technology areas which have been defined and identified by the sensor development areas. They also have done a lot of work on LiDAR development. So they have demonstrated a LiDAR up to 300 meters. And these are some of the advanced R&Ds being done at the optical sensors, one being Dyson spectrometer or the UV and Raman spectrometer development. These are again some of the detector development which is being done in-house at sensor development area. Regarding mechanical engineering systems area, it basically binds all the payload areas. So the main focus would be sensor payload or a sensor configuration on a satellite. The right side top image which you see is the OceanSat-3A satellite, which has 2 optical remote sensing and 2 microwave remote sensing cameras. So the field of use clearance is being studied there. 2 of the systems are rotating systems, so they have a very small jitter which can develop. So the other 2 payloads which are very sensitive to jitter. So this is how the configuration of the satellite is to be done, so that both the payloads can complement each other and do not they do not interact or interfere with the performance of the other. Then we also have the structural design and optimization capabilities, thermal design and management. Then fabrication, we have a very precise fabrication facility at SAC. We also deal with dynamic and thermal testing. You can, on the top left, you see is the 3D printed structure of antenna being vibrated on a shaker table. And on the top left, you see RSAT-1B, entire payload on the thermo-vacuum chamber. These are some of the engagements which mechanical engineering systems area has in the payload development. And this is where I've identified some of the research areas. I'll not go into the details. And in the satellite and data processing, the focus is now on analysis and AI data ready. So the raw data, the data products which are then are ortho-connected, then they are radiometrically corrected, and then the features are added, information and features are added onto it so that we provide total analysis ready data. These are some of the technologies which the signal and image processing area have identified as a research potential. Earth and planetary science application, this is primarily the applications area for all the EO missions, right from food security to geoscience, water, ocean, and atmospheric studies. All the research areas are done in this area. For example, in crop, it will be crop production, crop insurance, precise and smart agriculture. In terms of environment, it will detecting air quality and monitoring, as well as detecting air pollutants. In case of water, it is like reservoir and river monitoring, flood forecasting,
Sir, please
groundwater
summarize.
monitoring.
Please summarize.
Yeah. 5 minutes. And for weather, energy, as well as in urban systems. These are some of the short-term, mid-term, and long-term technologies, advanced technologies which the EPSA has areas. Yeah, they have also started work on space science at SAC. So starting from terahertz astronomy, which is basically studies the formation of stars, from exoplanet research, which about ISRO has a plan for a satellite called as ExoWorld. Then multi-wavelength astronomy. We already have many satellites in orbit, so right from Exposat, VICE, Chandra, and Gaia. So data is being used for space science. Solar physics and space. The Aditya mission also provides us the information, as well as XSM and IS-1. So solar physics and space weather predictions are also done at SAC. Then magneto-hydrodynamics modeling, that is the star formation and accretion disk. So that studies have been done, as well as microgravity experiments. These are some of the technical infrastructure which we have at SAC, ranging from very high compact test range antenna to precision manufacturing. This is the detail about the Bhopal campus and various technical facilities. And I would like to say space is for everyone to contribute. I would like to urge all of the researchers here to contribute to the national goal and be partner to us. I would like to say is Dr. Abha Chabra from Space Application Center is the research coordinator. Much of the research which is published which will be going to release post lunch, all the technological areas wherein we require industries and academia help have been published there. I look forward to have fruitful deliberations with you all. Thank you.
Sir, you want to ask any question? Thank you, sir, for sharing those valuable insights with us. Now, I would request Shri P. Srinivasulu, Associate Director of the National Resource Remote Sensing Center, as our speaker in this session. We request you, sir, please disseminate the essential insights of research area.
Respected teaching fraternity, dear students, ISRO colleagues, good afternoon. You have heard some of my colleagues from the various other centers presenting information mostly related to rockets and then building satellites. Now, what I'll be covering here is once satellite is launched, specifically remote sensing satellites, NRSC takes over, and all the responsibility of NRSC is to collect the data, process the data, disseminate that information as data products for others to use it, and also generate some information products which will be used in national level projects. So I'll try to connect the research components along the way. So we have a primary center in Hyderabad, National Remote Sensing Center, to cater to various regional aspirations. So we have 5 regional centers. They will be working on national projects as well as some of the projects regional to that area. That means mostly state government projects they will be conducting. And we do have multiple antenna systems at our data reception center at Hyderabad. And also, since the remote sensing satellites in the LEO orbit will be making one revolution in 100 minutes. So in a day, around 13 to 14 orbits will be made. But it is not possible for an antenna fixed in one particular geographical location to gather that entire data in one day. So we need multiple stations. So then you need large number of stations distributed across the world.
So one better way to gather the information is if you have a Earth station at poles, all the orbits will be going through the poles, so you can collect information. So we do have one station in Antarctica. A team of 5-6 engineers will stay there entire year in that extreme weather conditions, along with the other research from NCPOR, and we gather data from there also. So whenever you are using NRSC data, it is coming not only from collected at Hyderabad, and we also have another antenna system at Jodhpur also. So broadly, we'll establish ground stations and generate a satellite and aerial data production. We also have an aerial wing. We have 2 aircraft. Of course, not in a production mode, on a research mode, we fly them to test various satellite sensors and validate the sensor before it is launched. At our Earth station, we have multiple antenna systems which operate in S, X, and Ka bands to receive data from various Indian and as well as some of the foreign remote sensing satellites. And some of the design aspects is we are achieved expertise in designing and developing through industry antenna systems and RF elements related to SXK band, and also high data rate data acquisition systems. And the antenna systems are multi-band systems. As some of you may be aware from the communications background, that data can be in S, C, X, and K, and many other bands. Primarily remote sensing data we receive in the X band and Ka band, wherever a higher data rate is there. S band is primarily used for the telemetry systems. And NRSC also develops servo control systems. We have our own servo control software which is used for all Indian remote sensing satellites. And when you look at the advanced R&D areas, related R&D areas, as well as we also currently work on is this next generation hardware designs. Initially, 30 years back, we used to launch IRS-1A, one of the initial satellites for remote sensing, which used to send data in 5.2 Mbps. Now what we are receiving is at 1 gigabit per second. So that is the change in the data rates that is involved. So typically, earlier data used to be recorded on magnetic tapes, huge tapes, which is of a 1 foot diameter and almost 2.5 centimeter width tapes used to be there, which will weigh 2.5 kg also. And the data will be received in real time. It will be played back at a very slow rate to dump the data into then VAX computer systems. Now we directly download the data into computing systems through a PCI Express based hardwares. And once this data is received, we develop a lot of applications in various domains like agriculture, soil, geology, urban, atmospheric sciences. I have just put in few slides just to give briefly how we work, which has a lead into the research component. When you look at one of the schemes, crop yield estimation is one of a very key decision any country has to make. If you make the right decision, you will be able to know whether you have a proper production, underproduction, or excess production, and accordingly you can plan whether you need to import well in advance or you can stock them for future use or export. Especially when there is an underproduction, if you don't take advance action, foreign countries will jack up the price of food grains because they know you need it. So these decisions will cost anywhere between few hundreds to thousands of crores for the country. So though it looked like innocuously like a simple classification problem on the screen for a satellite data, its impact on the national growth is very high. And in the digital agriculture models for simulating the models, like you know the current status on, let us say, last 4 weeks, what is the growth pattern of the crop. And if you are able to assess for next 1-2 months what it will be, it gives advance information for the state government's plan for supply of fertilizer production, or in case of if an impending drought is there, take corrective measures. So the problems here is, a technological problem here is, crop classification is one aspect when there is a mixed crop, and the other one is based on minor variations, you should be able to tell in advance whether a crop is getting into some problematic scenario. And for a disaster-related support, we gather this is not a continuous one, but whenever a disaster happens, data will be collected over that particular area, and many times we may not be able to give advanced information, but we can quickly give what is the level of damage that is happening, and which will help the local authorities to take mitigation measures. This one example, what you are seeing on the top is one of the stubble burn problem, what is happening mostly in Punjab area. So sometimes people will claim that they are not burning any stubble, but the next state will be complaining that a lot of stubble is being burned. So who will tell that, whose decision will be believed? So people can't be believed, so you make a decision using satellite data, which is a proof. But the problem definition here is we don't have thermal sensors on all satellites which will give data at a very high resolution. So you have to make decision with a coarser resolution satellites. So sometimes you may miss a smaller fires, or sometimes you may treat multiple small fires as a bigger one. So that is one problem area. This I don't want to repeat. Many times you will see you don't have the right kind of a satellite data for a given application and at the right temporal frequency. Sometimes you need at a regular interval. Some things are weekly, some things are fortnightly, like that. The technological challenge is use the available data, even if it is a coarser one, and try to make a reasonable judgment of the problem what you are trying to identify. That is the focus currently in remote sensing. Now, whenever an earthquake kind of a major event happens, okay, till it is a challenging thing, nobody is able to predict earthquake, a lot of studies are there. But what is the next best thing we can do is whenever that thing happens, if you can immediately report the level of damage, because spatially people may not be able to reach to all the places. If you can quickly tell what are all the areas the damage has happened, it will help the local authorities to take what do you call rescue operations. This is very important. Here the challenge is like this. Everyone can see a building collapsed. By the general change detection methods, you can always identify something has gone wrong, some change is there. But can you tell from the previous data whether how many story building collapsed? Say a single story building versus 10-story building, the damage is different. The type of equipment that has to go for rescue operation is different. So this kind of analysis is important. And this is also a typical problem nowadays. In change detection, we don't want to know just some change has happened. Suppose in a city, in an unauthorized area, somebody is constructing a building. Through change detection, you can always identify. It is not a big problem for local authority because they don't need to go there very next moment to tell what has happened. In next 2-3 months also is okay. But there are some change detection problems where quantification is essential. That means if in a forest some trees are cut, you need to know how many trees are cut and what is the biomass loss. Similarly, when destruction happens through earthquake, you should be able to assess quantitatively. This is the fundamental challenge that is being faced by remote sensing community. This I am putting forth for you. I still have 5 minutes, I'll speed it up. I'll skip this slide. And urban, I understand some of the members here are interested in urban related projects. We do a lot of projects for central government. Atal Amrit Mission is one of the major mission for urban planning in the country. That is okay, routinely we do it. What is the problem in this is if we are able to identify automatically from satellite images various features. Extensive research is there in feature extraction and detection of various things, buildings, roads, railway tracks, etc. But when you look at mapping, there is no 100% foolproof computing solution which will give me all the data. When we collect data, especially with the aerial, I might take 2 minutes more, ma'am, I'm just. In aerial data also, we collect data in 1 month. It takes 1 year for us to map the entire thing in very high resolution. So what we want is mapping solutions which will identify things without any commission errors. Commission errors means if I run a program on identifying building, if 100 buildings are there, I have no problem if my software identifies only 80 buildings because those 80 buildings exist. I can always initiate another manual process to identify remaining 20 buildings, but immediately I can push up the results of 80 buildings to the respective teams for decision-making process. Commission errors means if non-building also treated as a building. So anytime whenever a computing solution comes, it always comes with both. So now what we need to do is work towards solutions which will work 100% perfect, even if it is not to the full extent. That's the point I want to make. And another project is related to urban water body information system. As you can see in the images, how the entire lake in 2021 has been covered with a lot of vegetation, 2011 to 2021. To that extent, the water is getting contaminated and it is not usable for regular like water consumption, etc. So Government of India has taken up this project under Amrut itself. So all the lake areas are studied, and then the surrounding environment is, its land use, land cover is estimated, so that corrective measure is taken by the local bodies. So when it comes to land use, land cover issues, the problem here is you will not be able to identify changes that are happening under the vegetation. So you should know how to use a combination of both optical as well as SAR sensors. When it comes to water body related applications, you need to have skills in handling data, not only in optical, along with the digital elevation models to identify the slope and water flow directions, so that you can take corrective actions in to improve the situation. Like check dams in the top image, if you see, it will improve the water availability for cultivation or otherwise. Bottom case, you can see how suitable places are identified. I hope this cursor is visible here. No. Okay. The blue thing, what you are seeing on the bottom right, is the ponds identification, so that the crop cultivation can improve locally. And in this particular horticulture, if you see, in land use, land cover, based on the water availability, type of region, and also the weather conditions, proper areas are identified for horticulture. This has been done for Maharashtra. So these are some of the applications which we develop for various government projects. When it comes to urban, I think I have already briefed, but one of the challenging problems is identifying the thermal islands and hotspots in the cities. This is one of the prime problems that is being faced by the country. So we look forward for research contribution in these areas. And we also do forest-related mapping, because nowadays this new concept of biological richness of a particular area using various indices is being done. The problem definition here is how do you identify various tree species from one another from the satellite data without people going and manually counting or checking the trees. This is one of the important input for forestry people to plan for afforestation purpose as well as for land use. Bring out that wasteland into the community, local communities who are close to the forest, etc. If we can tell them the distribution of the type of forest, they will plan the things accordingly. And when we use aerial surveys using our own sensors and then procured sensors also on our own aerial platforms to develop high-resolution digital elevation models, which are necessary for various civil engineering and infrastructure applications. So you can't get the exact terrain information over a forest.
Please sum up.
Suppose, yeah. If you want to conclude, just 15 minutes, I'll take 1 minute extra. So you will need to know the terrain undulations also to lay out a pipeline or a dam, etc. So we will use LiDAR sensors to get the terrain information, because LiDAR being a very narrow beam, it can touch the ground also, passing through the leaves of a tree also. So we will be able to extract the terrain information, and that is one of the biggest input for even flood monitoring also. This is one of the major projects which we have conducted for various flood bases like Godavari, Tapi. Advanced flood warning is being given by NRSC using this data. I am skipping some of the slides because I have covered the important points there already. This is again like we generate the digital surface model. First from the optical image, terrain model will generate using the LiDAR, associated LiDAR information. And then ortho images like correcting it for height distortions because of the perspective view. And we also have a freely available average NG sensor, hyperspectral sensor with the NASA JPL, what we have conducted in various parts of the country. This data is freely available. It is collected in 2016 that can be used for people for research. And UAVs, you know, we are being used left and right. One of the challenging problem here is excessively high resolution data is a bigger problem in identification and crop classification. And also the stability of UAV is not as high as satellite. So it also gives you co-registration problems. So solution in that are expected as far as the UAV is concerned. And we are also working on building some of the UAVs and then collision avoidance. I think that those are also listed under the research components. Digital twin, you all know, but it calls for a huge amount of data. I only look at it that locally we can generate digital twins at a panchayat levels because the entire country developing a digital twin is a monumental task. And some events, this I have already covered. A major event happened in Telangana, one of the forest areas, single atmospheric event, large number of trees fell simply just like that, thousands of trees. So this is where we need to know, without counting, you should be able to quickly tell how many trees fell so that further plantation activity can take, and then it indirectly results in biomass and carbon sequestration information is required. I'm skipping this one or two slides, which I think the academy is generally exposed to these things. Object detection, I have already covered. What we need is without any commission errors. Our Earth and Climate Sciences area collaborates with a lot of universities. This is their collaboration in this particular region. So you can see some of the colleges might have represented here. I'm skipping one or two in geospatial thing. Broadly, I am just take 1 minute, ma'am. Just one point I'll touch. In the satellite data acquisition area, we look forward for component building and XXK and Q-band reception components, because we build the entire data reception chain at Shadnagar, and it has got a huge industry value also. And when it comes to data processing area, pixel quality layer generation, whenever a satellite data is given, this process of manually certifying the data before giving it to the user is a big, huge task, time-consuming task. If something can be done automatically, our delivery chain gets improved a lot to the people. This is one of very important problem. When it comes to web services, if you can give us a highly, image compression technique using the deep learning techniques so that the size becomes so small that our Bhuvan portal can service the data very quickly. You can see a faster update, like WebP kind of a thing. This is for maybe data compression, electronics and computer science people may be interested in. Agriculture thing I have already touched upon. Disaster also I have covered. So broadly, we work towards the Sustainable Development Goals, which are 17 goals by the UN, for which NRSC is a signatory. So whatever solution you give to NRSC is directly affects the human life. So that's what is the point I would like to make. Thank you.
Thank you, sir, for making us aware of such technicalities. Now, I would like to invite Shri Javed Sir Qureshi, Group Director, Master Control Facility, Bhopal. He will be sharing his vital knowledge on different research areas of MCF. Please, sir.
Yes, good afternoon to all. I am Javed Qureshi. I'll be just covering about what are the activities Master Control Facilities does and what is probable area of research for the academia where you can contribute for the works what we are doing it. So basically we are located here at two places, one in Karnataka at Hassan and another at Bhopal. The primary function of Master Control Facility is to have the control of all the geostationary satellites. As my earlier colleagues have told about the rocket and the satellites. Rockets are made by VSSC, LPSC and all those groups, whereas the satellites are made by URSC and Space Application Centers. Our responsibility is there, once the satellite is launched from the rocket, our responsibility is there to put the satellite into the circular orbit, which is at a distance of 36,000 kilometers away. So that is the primary function of Master Control Facility. So I'll just briefly touch what are the main operations. What we do is, as I have already told, once the rocket puts the satellite in elliptical orbit, the responsibility of Master Control Facility is to do the orbit tracing maneuver so that the orbit is made circular. So we carry out the orbit tracing maneuvers for all the geostationary satellites and put in a circular orbit. For carrying out these activities, we have to establish earth stations or the ground segment at various places along the globe so that we can provide the telemetry and tracking data. Once the satellite reaches to the space, that is the intended longitude, our responsibility is to carry out the payload testing of all the spacecraft so that the satellites can be operational and can be given to the users for all commercial applications. So this is the first phase of the operations during the beginning stage of the satellite from launch to another 10 to 15 days. Then the further responsibility is to keep the satellite in space for another 10 to 15 years depending upon the life of the spacecrafts. So we carry out the on-orbit operations, maintain the satellite in the intended orbit so that the user find the satellite in a fixed position. That is why we call geostationary satellites. So that is the responsibility we carried out 24/7 basis from both the places at Hassan and Bhopal. And the series of satellite what master control facility controls is communication, meteorological and the NAVIC series of satellites. The main vision of master control facility is to automate the operations whatever we are carrying out so that the human intervention in controlling the satellites is minimized. We carry out a lot of automations for doing the spacecraft operations as well as improvement in carrying out the orbit determination, maneuvers so that the satellite is maintained in the fixed orbit. And we carry out a lot of indigenized, because all these operations has to be carried out by the various earth station and the flight dynamic software. We have a collaboration with various ISRO centers for carrying out the in-house development as well as the developments within the center as well as with participation of industries and academia. So now I'll be covering on the major areas where we are looking for the research areas from the academics. I have pointed out some 5 areas where we look for the contribution from the academia. One is the phased array antenna, another is a geolocation systems, then a passive ranging system and a signal interception system. The phased array antenna generally for carrying out the TTC operation for all these spacecrafts, we generally use parabolic antenna because of the obvious advantage of having high gain and good noise performance. But the challenge in parabolic antenna is we require a very precise tracking mechanism because they are all electromechanical systems. We require a very sophisticated tracking mechanism so that the antenna can track geostationary satellite as well as geosynchronous satellite have an inclination depending upon the orbit performance. We are looking for some phased array where the academic contribute, which will provide the TTC operations be carried out in either C or KU band. And the specifications I have already listed down in the document. The second area, what is the challenge? What we face is once the satellite is put in the orbit, the satellite is freely available for any people to put up the signal over there. The challenge is the intended user should use the satellite. So there may be cases when somebody else, whether it is a user or an unauthorized user, put up the signal in the site and spoils the spectrum what we are using. Main challenge is to find the person anywhere within the footprint of the satellite uplinking the signal. So here the important thing what we are looking from the academia is to find a geolocation systems where we should use the time domain, time difference of arrival of signal from the satellite. Here I am giving an example over here is what is the technique what we are looking from here is suppose this is the satellite we are looking for the desired operations. There is somebody somewhere in the globe within the footprint of the satellites. He is trying to transmit a signal to our satellite which is he is not supposed to do it. So what we are looking for here is if this signal is picked up by some adjacent antenna or satellite also and it is received by the ground stations, 2 reference ground stations which can be nearby or can be slightly away also. By knowing the time difference of arrival of signal and the frequency difference of arrival of signal, we can compute the location of the interference source. So here what we are looking is it requires a lot of signal processing techniques which can be provided by the academia. The first thing what we are looking is they should have the front-end systems where we can receive these signals. We should have a receiver chain and do a signal processing. And the important signal processing where FDO and TDO can do is the complex ambiguity function. This area is specially to the electronics and communication people where we can use the signal processing technique like complex ambiguity functions and derive these 2 TDO and FDO constraints so that the location of the interference source can be located. And this is of vital importance to Even ISRO also, as well as globally also, it is very important to know this geolocation systems. The second area of research what we are putting up forward to the academia is generally for determining the orbit of the satellite. What we do is the conventional ranging system we transmit the signal to the satellite, receive the signal from the satellite and compute the difference between the transmitted signal and the received signal and determine the range of the satellites. So here we have to do the transmission as well as the reception. What we are proposing for the academia is there can be one technique where the signal coming from the satellite, we receive it, it can be a telemetry signal or it can be a communication signal, whatever generally the satellite uses it, and then compute the time difference of arrival of signal at different places across the globe, maybe within India or across the different country, and receive this signal and determine the orbit of the satellites. So here the advantage what we'll get is we did not have to transmit active signal to the satellite to determine its orbit. So here is one more area of research where academia can contribute to us. So here also we have to have a system architecture in which way all the reference stations has to be established so that we can determine the orbit of the satellites in a very passive ranging systems where receive only signals can be used. Another area what we are looking for is the signal interception systems. Once the satellite is put in the space, the satellite can be used for multiple applications for all the users. What we want is there has to be a signal interceptor systems where we can decode the signals without knowing the type of modulation. So the functional requirement of a signal interception system, what we are looking for is spectrum scanning. It should scan the entire spectrum, maybe a 40 megahertz or a 500 megahertz spectrum. Then it should do the carrier detection and classification, identify and classify whether it is a continuous signal or a burst type of signal, then carry out the RF characterization like finding out what is the bandwidth of the signal and what is the center frequency and what is the signal strength of those carriers, and also do the modulation analysis, detect which type of modulation the system is there, and also if required the content analysis so as to decode for what purpose the satellite signals are being used. So these are my areas of research which I am looking from MCA point of view, and these detailed specifications we have already put up in the response basket. So for this also we have to identify a front-end digitizer systems and a detection systems where all the signal processing can be done. So these are the areas which I definitely feel like I have given a very specific requirement to the academia rather than a broad idea what MCF is doing it. So in this specific 4 areas, if we can get a proposal from any of the academic universities, we'll be very thankful to all the universities if we can get a useful proposal from them. And thank you from my side. If any questions are there, I can answer for those things.
Thank you, sir, for a very nice presentation. Because we have our inauguration scheduled at 2:30. So with your kind permission, sir, can we shift the next talk to our next technical session? Okay, so now we'll break for lunch.
Thank you so much, sir, for such a valuable information. Now we will move for lunch session. I request all to be here before 2:30 p.m. as we have our inaugural function of CIC and Central Research Facility at MANIT, Bhopal, starting at 30 p.m. Thank you. 2:50. Okay. It's requested to everyone that you be here by 2:15 p.m. Okay? By 2:15 p.m. you be here. We will start the inaugural function.
respond? Mahesh? Mahesh? Hello, 1, 2, 3, 4. Mahesh, RSC Kolkata, can you respond? वो वेबएक्स का वो शेयर कीजिए देख स्क्रीन हेलो हेलो 1 2 3 4 आ रहा है हाँ RSC कोलकाता कैन यू रिस्पॉन्ड RSC कोलकाता स्पीकर इज ऑन ब्लू कलर ना Mahesh, can you hear us? Hello. Hello. Me. Hello. Welcome. Me. First priority connection.
Your audio is clear. 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 Hello. Hello.
Hello.
Hello.
Hello. Can you hello? 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 That video. Hello. Hello.
Hello.
Hello.
Hello, Nishant.
Hello, Nishant.
Am I audible?
Am I audible? Am I audible? Am I audible?
Video assistant.
No, echo is coming. Just 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 no, echo is. No, echo is.
What is this? What is this?
You are the you are the you are the Mishra sir, are you audible, sir? Mishra
Yeah,
sir.
you are audible. Only thing I am hearing continuously echo sounds, not one or two, multiple.
Yes,
Hello.
sir.
You are
Yeah,
audible.
yeah. Yes, sir.
Hello. Could you able to hear us? Could you hear us? Hear us? ISRO headquarters. ISRO headquarters.
Nishant, I am getting
ISRO
some
headquarters.
10 times your voice.
Okay. Echo is coming. Okay. Echo.
Not once. Your whatever you said is repeating at least 10 times.
Our audio video is clear. No issue. Yeah, yeah.
Nishant, can you say something else?
It might be connected from two systems. One from their sharing.
Yes, yes.
That's why
Either you will have to mute always. You will have Nishan sir, if we are audible to you, you can unshare your that video and we will try once again, sir.
Hello.
Mahesh, you are audible here at least. It is loud, clear. You are visible also.
Satish, myself.
You can maybe slightly zoom in more because I'm seeing table and all in front. No? That better to
Yes,
zoom in
yes,
more
that will.
to the chair.
Satish, you can.
Okay, sir.
Satish, you can.
Okay, sir.
Satish, you can. Satish, you can. Satish, you can. Satish.
No, Nishant, your voice, some serious issues are there. I'm getting each sentence repeated 10 times at least. But Mahesh, audio, there is no problem. I'm able to see him. I am able to hear him clearly.
I'll ask them to unshare first.
Hello.
Only MANIT issue, I think. Remaining all questions, it's fine, I guess.
Satish, could you able to hear me?
PRL, somebody is there? Somebody is there?
Satish, could you able to hear me? Satish, can you respond? Satish.
Sir, I think they are trying to screen share doing. They can stop it once and they are doing the screen share, sir. That for typing will stop. We'll stop and we'll see.
Sir.
Then one more trial we can do first. No, that is screen share they are doing. 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 No, that is screen share they are doing.
Hello, Satish. Hello, could you able to hear me? 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 Could you able to hear me? Could you able to hear me? Could you able to hear me?
There is a lot of echo. 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 There is a lot of echo.
Mahesh? Mahesh, can you just come and just... Mahesh, RSC, you are there?
Yes, sir. Tell me, sir.
Just speak. Yeah. This is fine. This connection no issue.
I think we're clear from here, I hope.
Yeah. Just go near, slightly near and speak. Speak something. Okay, you move to the side.
Karthik, you are audible. Just mute to yourself. Abhaman, you are there? Abhaman?
Yes, yes, I am there. Yeah, I am there.
For you also, you
If this is the product you switch off this one, you operate from there only.
Yeah, I'm from Sahara.
सर वही करना पड़ेगा अभी समझ आ गया
हाँ, आप जाके इसको इम्पोर्ट करना
From Sahara.
Abhaman, आपका भी को आ रहा है सेंटेंस को
Now I don't hear any echo because I hear, but now
Oh, now the sentence was clear. This was
yeah, this was now I can hear.
No, it's fine. It's fine for you.
वीडियो का शो
Can you just repeat? We are not doing
Satish, check 1 2 3. Check 1 2 3. Yeah, I'm there. Could you hear me?
म्यूट
Mahesh, could you able to hear me?
एक्चुअली इको वगैरह हो रहा है ना इको हो रहा है हाउ साउंड इको हो रहा है वो ऐसे
Mahesh, Mahesh, could you able to hear me?
मैंने वो कहा कि बात
Hello, checking RSC Kolkata, ISRO headquarters. Hello. Echo is coming?
Nishant, it is better now.
Now it's settled down, right? Hello.
But it is feeble. Still, it is slightly feeble.
Okay.
It is slightly hello.
Hello. Now it is okay? Hello. Okay, there we go.
Whatever Nishant you are speaking is not through microphone. It is just the normal voice. The mic output is not microphone.
Mahesh, could you able to hear me? Am I clear or it is not so clear? Okay.
वो बोल रहे हैं कि स्टिल रखना है, दर्शकों के ऊपर तो कोई मतलब ही नहीं है।
की जुड़ी अभी यही
नहीं कैमरा वहीं पे। हाँ ठीक है कैमरा यहाँ, और वही बोल रहे हैं यहाँ दर्शकों के ऊपर नहीं चलेगा। बात करके आ जाओ, तब ये प्रॉब्लम होती है।
करनी पड़ता 2-3 व्यूअर्स
एक काम कर दो ना, बिना कैमरे के वेबएक्स को कर दो डायरेक्ट। हाँ ठीक है कर दो वेबएक्स को डायरेक्ट वेबएक्स पे चलेगा, वो दिखाते हैं ना।
जा रहे हो
वहाँ गए थे ना, वहाँ थे ना स्वर्ग। वेबएक्स सेट कर दूँ, ये तो आ गया, मैं वेबएक्स सेट कर दूँ पहले। किधर किस कौन लाइव देख रहा है? हाँ हाँ वो चालू करो ना, डेस्कटॉप ऑडियो। किनको चाहिए? तो वो तो लैपटॉप से पहुंचेगा ना, उनके लैपटॉप से शेयर स्क्रीन कर रहे हैं, वो ऑडियो शेयर कर रहे हैं।
Can you confirm? Yes, sir. It is adequate here. Yes, sir. It is adequate here. Nishan, just give us timing. हो गया क्या? अरे यार उसने लिखी थी।
एक सेकंड मैंने 3 किसका है ये नहीं मैंने 2 कहाँ चलेगी ये मैंने 2 भी अपना ये कौन सा कैमरा हुआ है मैनेट वो होगा ना यूट्यूब से उठा रहा है फिर तो ये कैमरा तो यही है सेट वो मैनेट 3 है नहीं
Good afternoon, everyone. It is my great honor and privilege to welcome you all to the ISRO Academia Connect for the Central Region, hosted here at the Maulana Azad. It is my great honor and privilege to welcome you all to the ISRO Academia Connect for the Central Region, hosted here at the Maulana Azad National Institute of Technology, Bhopal. On behalf of the Science and Technology Incubation Center and the entire MANIT community, I extend a very warm welcome to all our distinguished guests, esteemed scientists from ISRO, academic leaders, faculty members, researchers, and students who have joined us from across the states of Chhattisgarh, Madhya Pradesh, and Uttar Pradesh. I would like to extend a special It is my great honor and privilege to welcome you all to the ISRO Academia Connect for the Central Region, hosted here at the Maulana Azad. M. Ganesh. It is my great honor and privilege to welcome you all to the ISRO Academia Connect for the Central Region, hosted here at the Maulana Azad National Institute of Technology, and all the other distinguished scientists who have come from different centers of ISRO like Space Center, Liquid Propulsion System Center, UR Satellite Center, scientists from ISRO, academic leaders, faculty members, researchers, and students who have joined us from across the states of Chhattisgarh, Madhya Pradesh, and Uttar Pradesh. I would like to extend a special welcome. It is my great honor and privilege to welcome you all to the ISRO Academia Connect for the Central Region, hosted here at the Maulana Azad. M. Ganesh. It is my great honor and privilege to welcome you all to the ISRO Academia Connect for the Central Region, hosted here at the Maulana Azad National Institute of Technology, and all the other distinguished scientists who have come from different centers of ISRO like Space Center, on Liquid Propulsion System Center, UR Satellite Center, scientists from ISRO, academic leaders, faculty members, researchers, and students who have joined us from across the states of Gujarat and Andhra Pradesh and Uttar Pradesh. Also, we'll be starting off the formal a few minutes when we'll be virtually joined by Honorable Chairman ISRO. Till that time, I would request all of you and wait for the Honorable Chairman and other distinguished guests to come online. Thank you. M. Ganesh will it is my great honor and privilege to welcome you all. The ISRO Deputy Director and all the other distinguished scientists who have come from different centers of ISRO like Space Center, on Cyclid Propulsion System Center, Osmo Satellite Center, scientists from ISRO, academic leaders, faculty members, researchers, and students who have joined us from across the states remain smooth and Andhra Pradesh and Uttar Pradesh. Also, we'll be starting off the formal a few minutes when we'll be virtually joined by Honorable Chairman ISRO. Till that time, I would request all of you and wait for the Honorable Chairman and other distinguished guests to come online. Thank you. M. Ganesh will it is my great honor and privilege to welcome you all. The ISRO Deputy Director and all the other distinguished scientists who have come from different centers of ISRO like Space Center, on Cyclid Propulsion System Center, Osmo Satellite Center, scientists from ISRO, academic leaders, faculty members, researchers, and students who have joined us from across the states remain smooth and Andhra Pradesh and Uttar Pradesh. Also, we'll be starting off the formal a few minutes when we'll be virtually joined by Honorable Chairman ISRO. Till that time, I would request all of you and wait for the Honorable Chairman and other distinguished guests to come online. Thank you. M. Ganesh will it is my great honor and privilege to welcome you all. The ISRO Deputy Director and all the other distinguished scientists who have come from different centers of ISRO like Space Center, on Cyclid Propulsion System Center, Osmo Satellite Center, scientists from ISRO, academic leaders, faculty members, researchers, and students who have joined us from across the states remain smooth and Andhra Pradesh and Uttar Pradesh. Also, we'll be starting off the formal a few minutes when we'll be virtually joined by Honorable Chairman ISRO. Till that time, I would request all of you and wait for the Honorable Chairman and other distinguished guests to come online. Thank you. M. Ganesh will it is my great honor and privilege to welcome you all. The ISRO Deputy Director and all the other distinguished scientists who have come from different centers of ISRO like Space Center, on Cyclid Propulsion System Center, Osmo Satellite Center, scientists from ISRO, academic leaders, faculty members, researchers, and students who have joined us from across the states remain smooth and Andhra Pradesh and Uttar Pradesh. Also, we'll be starting off the formal a few minutes when we'll be virtually joined by Honorable Chairman ISRO. Till that time, I would request all of you and wait for the Honorable Chairman and other distinguished guests to come online. Thank you. M. Ganesh will it is my great honor and privilege to welcome you all. The ISRO Deputy Director Deputy Director and all the other distinguished scientists who have come from different centers of ISRO like Space Center, on Cyclid Propulsion System Center, Osmo Satellite Center, scientists from ISRO, academic leaders,
हेलो हेलो मैं जो बोल रहा हूँ हाँ नहीं नहीं चालू है लेकिन जो साउंड में बोल रहा हूँ वहाँ जा रहा है कि नहीं जा रहा ये बोलने के लिए हेलो आ रहा है
Ladies and gentlemen, sincere namaskar. On behalf of the Maulana Azad National Institute of Technology, I extend a cordial and warm welcome to all of you. I would like to extend sincere welcome to Dr. V. Narayan, Secretary, Department of Space and Chairman, Indian Space Research Organization. Thank you, sir. Sir has joined this program virtually from Kolkata. I would also like to welcome Sri M. Ganesh Pillai, Scientific Secretary, Indian Space Research Organization, who has joined the program virtually from Bengaluru. Today, we have gathered here at the inauguration program of ISRO Academia Connect for Central Region. Now, I would sincerely like to request Sri G. Harikrishnan, Director, Capacity Building and Public Outreach, Indian Space Research Organization, Professor K. K. Shukla, Director, Maulana Azad National Institute of Technology, Bhopal, Dr. M. A. Paul, Associate Director, Capacity Building and Public Outreach, Indian Space Research Organization, and Professor Savita Lima, Coordinator, Space Technology Incubation Center, MANIT, Bhopal, to kindly come over to the dais and take your respective seats. I would request Professor Savita Lima, Coordinator, Space Technology Incubation Center, MANIT, Bhopal, to kindly deliver the welcome address.
Namaskar. Respected Dr. V. Narayan, sir, Secretary, Department of Space and Chairman ISRO, Sri M. Ganesh Pillai, Scientific Secretary ISRO, and Sri G. Harikrishnan, Director, Capacity Building Program, Office, ISRO, Dr. K. K. Shukla, Director, MANIT, dignitaries from various centers of ISRO, coordinators of RSCs, SSCs, and STICs from across India, distinguished academicians of Central India, researchers and invited guests, and press and media. A very warm welcome to all of you. It is an honor and a privilege to extend a heartfelt welcome to this prestigious gathering on the occasion of ISRO Academia Connect for Central Region, encompassing Chhattisgarh, Madhya Pradesh, and Uttar Pradesh. We hosted at MANIT Bhopal. We are deeply honored by the presence of visionary leader from ISRO, Dr. V. Narayan, Secretary, whose vision and leadership will continue to inspire generations of researchers and scientists across India. We are also privileged to welcome Sri M. Ganesh Pillai, Scientific Secretary ISRO, and Sri G. Harikrishnan, Director, Capacity Building Program Office, ISRO Headquarters. Your presence here today truly signifies the strength of collaboration between ISRO and academia. We are deeply honored to have with us eminent dignitaries from Indian Space Research Organizations. I extend a most sincere welcome to the group directors and experts from Indian Space Research Organizations who have joined us today for ISRO Academia Connect for Central Region at MANIT Bhopal. We are deeply honored by your presence here, sir. Your leadership, vision and technical expertise have been the cornerstone of India's remarkable journey in space science and technology. Today's event is a celebration of ISRO's outreach to the academic community, and your presence marks the strength of this collaboration. A very special warm welcome to Professor Ganesh Kumar Shukla,
Director of MANIT Bhopal, whose unconditional support and leadership have been instrumental in hosting this event. I also extend a warm welcome to all our fellow academicians. Your presence here today is a reflection of collective aspiration of our region to contribute meaningfully to national scientific goals. The inauguration of Space Technology Incubation Facility and Central Research Facility at MANIT is a step forward in creating collaborative platform where research meets real-world applications. ISRO Academia Connect program for the Central Region is a step to bring together esteemed institutions and academic leaders from Chhattisgarh, Madhya Pradesh and Uttar Pradesh to take forward a vision of creating a vibrant and inclusive research ecosystems that taps into intellectual potential of Central India. This initiative, taken by ISRO in collaboration with academic partners, marks a new chapter in strengthening ties between India's partner premium space agency and our regional academic institutions. Today's program marks a significant milestone with the inauguration of STIC and CRF at MANIT Bhopal. These initiatives symbolizes a commitment to empowering innovation, research and capacity building among young minds and researchers in central region of our country. The release of research area in Space 2025 will further strengthen the roadmap for academic institutions to engage with ISRO pioneering research domain and national missions. Let this be a call to action, to collaborate, to innovate, to encourage our students and scholars to participate in nation building through space technology and research. Once again, on behalf of MANIT Bhopal, I welcome each one of you. Let us make the most of this opportunity and work together towards for a brighter research-driven future of Central India for the nation. Thank you.
Thank you, ma'am. I will now request Shri G. Harikrishnan, Director, Capacity Building and Public Outreach, Indian Space Research Organization, to kindly enlighten us by delivering the introduction about today's program.
Respected Secretary, Department of Space and Chairman ISRO, Dr. B. Narayan sir, Director, MANIT, Dr. Ganesh Kumar Shukla sir, Scientific Secretary ISRO, Sri M. Ganesh Pillai, STIC Coordinator, Professor Savita Nema, distinguished speakers and invited guests, eminent faculty and students. Good afternoon to all. It's an honor to address you today at the ISRO Academic Connect program for the Central Region. I am truly delighted to be a part of this remarkable gathering that signifies the ever-growing synergy between ISRO and the academic community. ISRO has a vibrant academic interaction program which includes the sponsored research program RESPO. We also have 6 regional academic centers for space and 6 technology incubation centers located on each of 6 regions of the country. Apart from that, we have 9 space technology cells located at IITs and IISc. The research area in space document is a biannual publication by Capacity Building and Public Outreach Office of ISRO headquarters with the support of both ISRO and those centers and labs. This comprehensive document outlines key areas where academic research can make impactful contributions to the space sector. This document is an invitation to the brightest mind to delve into space research and work alongside ISRO in realizing the nation's vision for space exploration and technology advancement. Today is also a momentous occasion as the STIC facility is being inaugurated at MANIT campus by our beloved Chairman ISRO. It will serve as a hub for innovation, collaboration, and the nurturing of scientific talents. This facility is a testament to our commitment to fostering research and development through academia-industry collaboration. I firmly believe that the space will soon become a beacon of creative ideas Through the Academic MANIT program, we aim to provide the academic community with resources, support, and opportunities to actively participate in space missions and research projects. I am confident that the ideas and collaborations fostered through this platform will greatly benefit India's space endeavors. I urge all faculty members and participants to please participate, go to the research areas in space development and submit the appropriate proposals to STAC and RSS. In conclusion, I would like to express my gratitude to all the participants and organizers who worked tirelessly to make this event a reality. Let us continue to work together to unlock limitless possibilities that space offers. Thank you.
Thank you, sir. I would now request Sri M. Ganesh Pillai, Scientific Secretary, Indian Space Research Organization, to kindly deliver your address. Sir.
Very good afternoon to all. Respected Secretary US, ISRO, Dr. B. Narayan, Director, MANIT, Professor P.K. Plaza, Director, CVPO, Hari Krishna, STAC Coordinator, Professor Kavita Nema, distinguished speakers, and invited guests, eminent faculty, and students. Very good afternoon and a warm welcome to this occasion, the inauguration of the ISRO Academy of Connect at Maulana Azad National Institute of Technology, Bhopal. It's my privilege to address you on this landmark day, which also marks the release of the research area in space document and the inauguration of the Space Technology Incubation Center facility. The ISRO Academy of Connect is a strategic initiative to bridge the gap between ISRO's cutting-edge space research and the academic progress of the institutions like MANIT. This collaboration is designed to foster innovation, facilitate knowledge exchange, and address critical challenges in the space technology through joint research and development. MANIT Bhopal, with its distinguished legacy in engineering and research, is an integral part in this endeavor, poised to contribute significantly to the Indian space program. The ISRO Academy Connect will bring colleges from UP, MP, and Chhattisgarh. With nearly now, currently I think our 250 plus colleges together, and I'm sure we'll get more projects in various areas. That is our basic target. The research areas in space 2025 document we released today is a pivotal resource. It's a meticulously outlines priority areas for space research, including launch vehicle systems, satellite technologies, human space program, Earth observation, space science, space policy and management. This document will guide researchers and faculties to align their efforts with ISRO's mission, ensuring that their work addresses real-world challenges and advances our nation's capabilities in space. It's a roadmap for transformative discoveries, and I encourage the academic community to leverage it to drive impactful projects. The inauguration of the Space Technology Incubation Center at MANIT Bhopal is a significant step towards nurturing innovation and entrepreneurship. STIC will provide a platform for faculty and students to collaborate with ISRO experts, develop prototypes and products focused on space technologies, by fostering an ecosystem of creativity and technical excellence. STIC will accelerate the translation of ideas into solutions that strengthen India's space ecosystem and contribute to global advancement. It will serve as a catalyst for groundbreaking research, fostering collaboration that pushes the boundary of scientific knowledge. As Scientific Secretary, I assure you that ISRO is committed to provide technical guidance, resources, and mentorship to ensure the success of this partnership. To the faculty and researchers, your expertise will be instrumental in shaping the research agenda. To the students, your curiosity and inspiration of the driving force behind this initiative. Together, let us harness the opportunity provided by the ISRO Academy of Connect, STIC, to make meaningful contribution to India's space journey. With great anticipation, I look forward to the transformative outcomes of this partnership. Let us work together to explore new frontiers in the space science, technology, making India a global leader in the cosmic arena. Thank you, Jay.
Thank you, sir. I would now request Professor Karunesh Kumar Shukla, Director, Maulana Azad National Institute of Technology, Bhopal, to kindly deliver your address.
Narayananji, Chairman ISRO, Dr. M. Ganesh Pillaiji, Sri G. Hari Krishnanji, Sri M. A. Pali, Professor Savitanima, scientists from different centers of ISRO, faculty colleagues from different academic institutions. I could see some students, I don't know whether they are here or not. Good afternoon to all of you, and indeed welcome. I extend my hearty welcome to all of you in this formal inaugural session chaired by Chairman ISRO, Dr. B. Narayananji. And I am happy to note that at least we have started to connect with research organizations. Of late in academia, we were working in silos. We try to conceive our problem, we try to address those problems, solve it, and if we publish the papers, it's straight, we get some degree and that's all. But what is the need of the hour? That whatever the problem you are conceiving, whether it is useful to the society, to the country at large or not. So time has come that we must break all the boundaries of the silos. We must try to interact with different research organizations like ISRO, CSIR, so on, DRDO, as well as with the industry partners. And this is the mandate for us now, apart from teaching, training our undergraduate students to contribute to the development of missile by way of research. So whatever we are doing till now, we are happy at the level of the LG or 4. But the time has come that we should translate it into reality. Is whatever we are doing in the lab, it has to be translated in the language. So we need to move forward. We are here at 5 or so. In this connection, I congratulate and I place my sincere thanks to the ISRO that having a space technology incubation center at MANIT, which we are going to inaugurate today itself at the Honorable Chairman. I know that few of our faculty, they are addressing the problems. I would like to see many more faculty coming forward to address the problems related with this space, why it is so. So if I would like to summarize the space organization ISRO in one sentence, the best fitting sentence I have to take it from Bhagavad Gita, chapter 10, verse 8, where the Lord Krishna has said, it exemplifies that he himself is the universe. So ISRO signifies the Lord Krishna in this context today itself. It said, Aham sarvasva prabhav matta sarvam pravartate. Ki hami sab jagah vyaapt hai. You might have seen recently we have some conflict with our neighboring nation. And we successfully and very precisely hit the locations. How it was possible? Definitely with the research and the work which we have done in the past in space. Because now you have so many satellites have been launched by India, and we can capture the image of even your house number can be captured very precisely. Even I think today or yesterday I was reading the newspaper where it is said that America is going to have some warfare in the space, and they will set up something there. So the land is filled up now. We will go to the space. Maybe after 30 years down the line or 40 years down the line, we have another Bhopal in the space. And we are going to control. Now the days has come that everything has to be controlled by the space only. Even in this today's scenario, what we have witnessed, the surface to surface missile, air to land to surface missile, air to air, air to air. So it has drawn the relevance or the attraction. So I call upon my faculty colleagues, the students, the researchers, to discuss with the scientists from the ISRO As I was discussing yesterday, they told that they will be coming up. I have already discussed with some problem statements. So please take those problem statements, whatever the academic competency, core competency you have, you work in a synergistic way with the scientists at the ISRO and try to address the problem. I would like to see many more problems being addressed by the faculty and students of MANIT and other academic institutions so that we can contribute at least to the development of the nation. With these words, I once again place my sincere thanks to the Chairman ISRO for blessing this occasion, and I wish to see many more collaborative work in future with MANIT. Thank you, take care, Jai Hind.
Thank you, sir. I would now sincerely request Dr. V. Narayanan, Secretary, Department of Space and Chairman, Indian Space Research Organization, to kindly release the Research Area in Space 2025 document. I would also request all the dignitaries on this stage to kindly release the same document of fact. I would now sincerely request Dr. V. Narayanan, Secretary, Department of Space and Chairman, ISRO, to kindly inaugurate the STIC facility and the Central Research Facility at MANIT Bhopal and ISRO Academia Connect at the Central Region virtually. Yes, sir. You are audible, sir.
Audible. Respected Director, MANIT Bhopal, Professor K. Sulaji, Science Secretary, Mr. Ganesh Pillai, Professor Samita, being our coordinator, who is going to play a very crucial role in our activity, Mr. Hari Krishnan, Director, the person with the program office, ISRO headquarters, and Dr. Kumar, Associate Director, the person with the program office, ISRO headquarters, and my dear friends, and the faculty members from the MANIT Bhopal. Very good afternoon, all. It is with immense pleasure I am with you for the inauguration of these two activities. Inauguration of the STIC facility at MANIT, also the inauguration of Central Research Facility at MANIT Bhopal. As a very sad coincidence, which is MANIT and myself, I understand it started as a normal polytechnic in the year 1960 and grew to the institute which gives degree in the year 1963. Today, almost 6,000 plus students and 275 plus faculties dealing with excellent subjects like artificial intelligence, energy, water management, product design, smart manufacturing, and all those things are happening. And we are extremely happy with a couple of points. Number one, this institute is named International National Institute of Technology Bhopal. Is named on a freedom fighter and great son of India, the first education minister of independent India. I am very happy that this institute is named on this great son of India. And you have grown to greater levels from a bilingual status to the status of distinction. And I also started my career with a degree from the Party, not degree from the Party, and that was in 1982, I completed the joint organization in 1984, and probably it is with great honor and privilege, and have been groomed, mentored by all the bosses, seniors, and teachers. Today I am with you for this important thing. We will talk about the space program. The space program in the country started. Actually, the seeds were put in the year 1961. You know, obviously, it says started in 1962. And I understand because Sarawat, the father of the space program, and Professor Chitnis, who is going to be 100 years in July this year, right now in Pune, both were discussing about starting this program. And at that point of time, 1962, the country was not having that nature to start this program. In fact, it was literally any analysis, economic analysis and technical analysis at that point of time to start this program. So then they said, surely it will, the advanced technology will get into the picture on and on this country. And they started the program. Why 1962? Because in the year 1984, I was working here. DHL Ranipur, then I got the offer from ISRO. And so many of my colleagues were not that enthusiastic, myself deciding for DHL and joined ISRO. Because the state of the space program was just the space program was going. And then, dear friends, when we started the space program in 1962, and when ISRO was launched on August 15, 1969, that was a very important year, 1969. Manas rocket, Neil Armstrong has landed on the moon and come back safely. And ISRO is just to bomb. One tiny rocket, indigenous rocket is launched. And we are truly 60 to 70 years behind the advanced nations in the space program. From that stage, today, a country which was carrying rockets in bicycles, old bicycles, rocket pods and taken for assembly for launch. And today we normally broke the sun. And we touch. In the area of launch vehicle, rockets, Saudi rockets are launched, because Saudi rockets are launched. Launch vehicles, 6 generations of launch vehicles are developed, realized, and would not go to missions jobs. Of course, there were a couple of setbacks, enabled us to study a lot on the launch vehicle systems. But very happy to note that even though the first launch was not successful, the 100th launch this year, the most complex rocket was able to be successful mission. In the area of satellites, we have from the long way, the first satellite area with the support of other foreign countries was accomplished in the year 1975, 19 April 1975, and 50 years have passed. And during the 50 years of growth is now such a 132 satellites of different classes, different varieties, different payloads are conceived, built, and launched and placed on because of the 56 spacecraft are like adding to the sky, doing a great job in ensuring safety and security and multiple areas which is helping the Indians. And dear friends, in the area of application, 50 years back, because in the year 1975, the country demonstrated the site program that placed 2,400 television sets in 2,400 villages. And through the agency satellite communication demonstrated this country, the mass communication will be possible through the satellite system. And from that, today we will come, after 50 years, we are having more than 50 applications serving the common man of this country in multiple places. Television broadcasting, telecommunication, environmental studies, weather forecasting, climate studies, and ensuring food security, water security, and security for the country. The country is carrying almost 11,500 kilometers of seashore, and the non-portable neighbors, and it's our responsibility to monitor and ensure the safety and security of the more than 100 satellites for the first rocket. And the denied gravity technology made 3 places number 1. With just 3 engines at the shortest time to the cheapest to flight. And the other countries were thinking that we don't have anything, we cannot have a meaningful program and make it a denied technology world record. 3 places standing number 1. And had this be a docking experiment accomplished that India is the only 4 countries having that great accomplishments. Building a satellite to study the sun and bringing a lot of scientific data from the sun, and India will be one of 4 countries having the great satellite called RBJ and placed chemistry in the yellow orbit and utilized. It is not only chemistry, actually you should see almost 5 to 6 terabytes of data, scientific data has come. And India discovering exoplanets. And there was a time the exoplanet is not available. We are discovering exoplanets. And on the Mars orbit mission, we are the only country, first country, accomplishing the Mars orbit mission, traveling 68 kilometers and succeeding in the first attempt. And none of the development countries could do the first attempt, succeed in the first attempt. Now, the country which was not a satellite technology, building satellites and launching and donating to our neighbors. Actually, our country, the different country, we always feel that our growth alone is not adequate, and the humanity growth is important, and and supporting whatever possible. In terms of infrastructure, in terms of capacity building, we are trying manpower, not only India, and Indians and other countries, in institute like Institute of Motions, development, and places and these are starting a global academic space academy, and we have a long way. Now, dear friends, we had all these success. It is not only ISRO which is responsible. It is the academia who are always interested in the journey. The industrial partners, both the industries across the country, they are contributing significantly. Without industry, without academia, I cannot think about a space program. Now, in order to have a vibrant space ecosystem, and in order to make a vibrant system and come involved in other countries, we have to connect throughout the country with startups, with academia, other pieces. Academia, I want to tell the strength of academia and weakness of academia to understand. They always update their knowledge. A teacher from the MANIT or IIT simply cannot have a written knowledge, 40 years old written knowledge, they go to the class, they will be thrown out of the class. And they cannot simply manage. And I know the teachers in IITs, and advanced engineering colleges, they update the result. They are close to the current development. I don't say that ISRO, we are not close to the current development, but our responsibilities are ensuring the hard work, coming out that we are making the rocket launches, satellite launches, and advanced programs. But whereas academic people, they are having the strength is they are close to the current one, but the weakness is in the current situation. There is a lot of gap between hardware, application oriented software, and simply we can criticize. Academia is not done. The academic that to take the use of the ISRO, they are having world market. That is not it. To bridge the gap between academia and ISRO so that we go together and make this country space program as a vibrant space ecosystem. That is what we do. Therefore, this academic connection is going to be in fact, the first, the great institution leader, Professor Satish Dhawan, when he was the chairman, the response program was started in the way back in 1970s. He was by profession, he is a great scientist, great orator, and he was a academician, and he was given the responsibility of leading ISRO after Sarawak. not for the experience. And main reason is not that this activity is bad, because not because of the proper connectivity between ISRO and academia. If you have research output, even the academic is just to really professional and compensate good output, there should be continuous interaction. Without that, the output will not be that useful. The output will not be as we want. Even the output will not be as we want. So there should be a clear connection. And today, we are also starting. We have got about regional academic centers and 6 space technology education centers. And what we are starting is the MANIT, is the central part of activities going to be taught in sectors. MP and service again. So much about, so many engineering projects, so many academic students, I think they are going to participate. And I am extremely happy that the institute started with the diploma course and taking the role. I think let us give a big hand to all the and I want to go to much higher levels, international standards, and we should gain much higher. And we are to whatever they possible, we are same, there is a saying, step only was unless you rise to that peak, you also can't nobody was. So I have no suggestions. You should be a two-way traffic, not a one-way traffic. And surely the way the honorable director addressed, I can understand his enthusiasm and dynamism. Surely you put a vibrant system there to enable the faculties and students to contribute in a significant way. Same way, we are having 2 dynamic personalities. So having students in the first degree program of this very year, compared to average level of the English 72, and average level of the 72 there the language up to 100 years because we know the average will be 72. So it's so young and dynamic, and dynamic is boss under dynamic person, and then under this type of people and some past here they better. And under this type of people only truthful interaction will take place, and we will get real benefit out of it. And unless we have got mutual trust and mutual strength, I think things will not go. And our submission, I am extremely happy. I was so happy to come directly. Sir, I want to tell you, at the earliest opportunity I can come to your institute. Because unless you come directly, about there is advantage China. But rather is I am not really getting the direct body language of the community. By seeing the body language, I also get a lot of difference. That is see the part. You are not responsible, I am responsible. So I am sure at the earliest opportunity I want to back out of the country and find there. And I have got a great respect for teachers of the I want to tell you, because the teachers are the ones who want the next generation who are wanting to do something. It's not only professional. Say when you talk about a vibrant India, we talk about a developed India, the India also should have got disciplined citizens. And the teaching practices are what really improve the students. Not only become great technocrats is great. Not only become their scientists, yes, that is the truth, but also to become good human beings, and also to carry life, also to contribute to the society, also to ensure the overall personal development takes place within them, also to ensure they take care of their parents. Simply after something, partly because parents are looking at the villages from where they are going to do something. And all these are the bad story. I am sure you are the great work to contribute to the overall personality, and I am sure you are doing that. Now, with this new guys, let me wish this incubation center contributing a very big way, and we are with you to take scientific to greater and greater heights. And with this, let me formally inaugurate this incubation center on very, very important thing. Thank you. Thank you.
Thank you very much, sir. I am very sure that your words of wisdom, experience, and the knowledge that you have shared with all of us today would certainly go a very long way in ensuring that our country gets the status of Viksit Bharat by the year 2047. Thank you very much, sir. Once again, I would now sincerely request Dr. M.A. Paul, Associate Director, Capacity Building and Public Outreach, Indian Space Research Organization, to kindly deliver the keynote, the vote of thanks.
Respected Chairman ISRO, Dr. B. Narayanan sir, Scientist at ISRO, Sri M. Ganesh Pillai, our Director MANIT, other dignitaries on the dais, good afternoon to all of you. As Chairman just now mentioned, the academia interaction with academia started around at the time when ISRO was started. That as Chairman mentioned, in the 1970s. This program was started as called Sponsor Research called Respond. And from that, what's beginning, this program has grown from strength to strength, and many new programs have been added to that. In 1980s, we have started the space technology cells as part of this Respond scheme. Then we have started, very recently, we have started the research, RSCS, research, academic research centers in 6 places, and space technology incubation centers also in 6 places. So one such center is located in MANIT here, so that is why we are all here. So the main aim of this Academia Connect program is to create awareness about the various schemes, various programs for available in ISRO for the academia, and the faculty and the students to participate and contribute towards the benefit of the Indian space program. So on this occasion, we are really grateful to Chairman ISRO Secretary DOS, Dr. B. Narayanan sir, for his presence and addressing the delegates in spite of his busy schedule. So his dynamic leadership and motivation is the real force behind all the activities of ISRO. So we are also grateful to him for releasing the research areas in space document and also inaugurating the STAC facilities and CRF facility here. So thank you very much, sir, for sparing time with us, sir, in spite of your busy schedule, sir. Thank you. So Professor Shukla sir is the Director MANIT is with us, and he has played a key role in making all this possible. So we are really grateful to him for hosting this event here. Thank you very much, sir, for your guidance and support for this event. And see, M. Ganesh Pillai is the Scientific Secretary of ISRO. We know that he is a very busy person because he has addressed from Bangalore. So a lot of parallel activities are going in ISRO. He is being the Scientific Secretary. He has to play a major role in most of those activities. So he could not make it in person. But I am really grateful to him for addressing us in spite of his busy schedule. Thank you, sir. Sri G. Harikrishnan, Director CDPO, has played a very major role for organizing this event. So he played a key role, and also meticulously is following up. Every day he was asking how is the participation going on, how many whatever he stayed, what are the arrangements made, all these things. So he played a key role in organizing this event. So thank you, sir, for all the support you have provided for this. So Professor Savita Lema, coordinator STAC here, she was on constant touch with us, especially with Nishant, for organizing this event. So thank you, madam, for all the effort you have put in this event. So I also thank my colleagues Nishant, Nirupama, Uday, and Sri Mahesh for bringing on this document what we released today. And they also played a major role in organizing, planning and organizing this event today. So I thank all of them. Okay, I also thank all the speakers. We have got very good illuminary and very experienced people here from various centers of ISRO and some of the institutes. So they have taken a lot of strain to come over here and be with us. So I thank all of them for all the efforts they have taken and come over here to participate in this program. I also thank all the participants It is because of you only this program is successful. So your whatever the effort and strain you have taken to come out here and your interest in the InterSpace program, research activities of InterSpace program. So thank you one and all for the participants who have come through. So I also thank all the staff, students, research colleagues, and other supporting staff who was helping us in organizing the event and make it as a grand success. Thank you one and all.
Before we go on to have the formal closure for today's inauguration ceremony, I would request everyone to be just ready for having a group photograph, and then we will conclude the program. I would request the respective dignitaries on the dais to kindly come in the front so that we can have a photograph involving everybody who is in the hall and who is also available here virtually on the screen. And with this, I declare the closure of this inaugural session. Thank you very much. Yeah.